I had a hard time getting started with programming. Lingo I didn't understand, theory I didn't need, and setup that required installing random programs on my computer. I just wanted a simple, easy way to build. Build an awesome game, a stunning website. I only wanted to learn the necessary parts of code, not memorize the whole coding encyclopedia. If you feel the same way, this course is for you. My name is Alvin. Today, I'm a research scientist at a large tech company, and I was formerly a lecturer at UC Berkeley, where I taught over 5,000 computer science students on campus. This class is for any beginner to take. You could be a painter, a designer, a product manager, anyone. You won't need to install anything on your computer. To make it easy for you to get started, we'll use a free online tool at 𝐵𝐞𝐬𝐿.com. No accounts, no installation, just code. In this course, we're going to use a coding language called Python. Python is my language of choice for software engineering, cutting-edge AI research, web development. I want you to see how even simple tools, short code snippets can benefit you today. Once you finish this class, you'll have the power to automate parts of your daily life with Python. There are two goals for this class. Goal number one, I want you to get excited. Show you what's possible with just an hour of code. If you're already excited, you know what you want to build, even better. You're a step ahead. Goal number two, give you just what you need to start learning. We won't go over laundry lists of coding utilities. I'll give you what you can't Google here, so that you can ask Google for more examples. I'll give you the framework so you can ask ChatGPT for the details. I'm excited to share with you the power of code, to share the same excitement and thrill. It's not some distant, hard-to-reach enigma. All you need is a computer, internet, and an hour of time. Let's give coding a try. Welcome to Coding 101, Python for Beginners. Throughout this course, you will learn not just how to write code, but also how to talk about code. We will emphasize specific lingo that coders like you use all the time. We will also go over ways that code can go wrong and what certain errors mean. First is our course website. All of our finished code and additional resources can be found at this URL. Note that I highly recommend viewing course resources and coding along on a desktop. Coding isn't very mobile friendly because of all the punctuation you need to write. Let's start with a few tips for this course. Tip number one, copy my code exactly. Many parts of code, such as spaces and punctuations, are critical for code to work. I will emphasize which parts of code are needed and which parts aren't, but to err on the side of caution, copy my code exactly. Tip number two, pause the video when needed. These aren't live lectures, so if you need time to process what I just said, don't hesitate to pause. Likewise, if I'm talking too slowly, then of course, you can speed the video up. The third tip is to please code along with me. You learn code by going through the motions and practicing, so if you also practice writing code in our interactive lessons, you'll take away a lot more from this course. To write code, you will use a website called 𝐵𝐞𝐬𝐿.com. I suggest placing your Skillshare videos and 𝐵𝐞𝐬𝐿 editor side by side like this, so that you can still see the video when minimized. I intentionally designed all the slides to have much larger fonts. I also zoom in 200% on my editor. My last tip is to ask ChatGPT if you're stuck. Simply copy and paste code into ChatGPT and include the error. You could also use any other AI service like Bing's Copilot, Google's Gemini, or Anthropic's Claude. So you may be wondering though, if AI can already write basic code, why am I learning basic code? Well, even though AI can generate code, someone needs to be able to read, understand, and pick between different options that AI provides. As a result, your emphasis is actually on reading and understanding code. It just happens to be that learning how to write and speak a new language, like coding, forces you to understand it deeply. So this is why you're writing code that AI can also write, so you can double check and assemble the code that AI generates. And that's it for our brief introduction. One last note is that you should feel free to post questions and tips in the discussion section in Skillshare. I've seen the posts there, and you are all an insane community, helping and propping each other up when something goes wrong. I am really grateful and simultaneously very proud of the community here, including you now. So in honor of that, I've marked slides throughout this course that have incorporated student feedback from coders just like you. So definitely post in discussions to help each other, to ask questions, and to be a part of this course's future. Welcome to the family. In this lesson, you'll write your very first lines of code. Start by navigating to pytwiddle.com. There's no need to create an account and it's completely free to use. We need to start with the types of data you can represent. Let's do this by jumping straight into the code. Just copy the code I have so you can see firsthand what your code does. First, here is the interpreter on the bottom half of the editor. The interpreter will read your input, evaluate that code, and return the resulting value. This blinking cursor means Python is waiting for our input. Let's add some code. Start with 5. Hit enter. Python evaluated and then returned 5. We can also have negative numbers, like -10. Hit enter. Python evaluated and then returned -10. These numbers are called integers, just like in math class. We can also have decimal values, like 3.14. Hit enter, Python evaluated, and then returned 3.14. We can have an arbitrarily precise number, like 3.14926365. 6535. Hit enter. Python evaluated and returned the same number. These decimal values, like 3.14, are called floats. You don't need to remember the distinction between integers and floats for now, but if you hear either term, just know that it means number broadly. So far, we've covered 2 data types that represent numbers. There are 2 more data types. One data type is text, which we call strings. To write a string, we need start and end quotes. For example, here's hello. Between these quotes, you can also add punctuation. For example, I love watermelon. You can also include numbers, so I love 3.14. You can add whatever characters you want besides the quotes that you used to denote the string. So for example, in this string, I cannot include double quotes anywhere inside of my string. Note that you can also denote strings using single quotes instead of double quotes, like this. These are all valid strings. Now remember, quotes always indicate a string. For example, quote 123 is not an integer, it's a string. To help distinguish between this and an integer, you might hear this called a stringified integer. Likewise, quote 3.14 is not a float, it's a string. We might call this a stringified float. Our final data type is just true or false, which we call booleans. For example, here's true. Notice the capital T. And here's false. Again, notice the capital F. If you forget to capitalize the first letter, you'll get a name error like this. We'll explain what this name error means in the next lesson. These are the 4 data types in Python. Let's now see how to manipulate these data types. To combine and manipulate data in Python, we need operators. For completeness, I'll cover several categories of operators. However, there's no need to memorize the categorizations or even the operators I show you. This is really just to get you familiar with writing and reading code. Combinations of data types and operators then make what we call expressions. Expressions can take the form data, operator, data. Let's see a few examples. Here's a simple expression, 5 plus 2. The spaces I'm adding are optional. They aren't needed for Python to work, but the spaces make your code more readable, so I would recommend you also add spaces to build good habits. We input 5 plus 2, and Python returns 7. We can also subtract 5 minus 2. Like before, Python will evaluate 5 minus 2 and return the result. I'm being deliberate about the use of the words input and return. We input 5 minus 2, and Python returns the resulting value 3. We'll see in a later lesson why returning is such an important concept. We can also divide and multiply. Weirdly enough, you can also apply math operations to strings. For example, you can concatenate strings together using addition. Hello plus world. As you can see, the strings are simply concatenated, making one big string hello world. However, note that you can't concatenate strings with other data types. For example, hello plus 1 is invalid. Here, Python complains. You can only concatenate strings, not integers, with other strings. We saw different math operations: add, subtract, divide, and multiply. These are arithmetic operators. We can also compare data with each other. For example, we can check if one value is greater than another, like 5 is greater than 2. Like before, Python reads the input, evaluates the expression, and this time returns true. This true, as we discussed before, is a Boolean data type. We can also check if two values are equal using two equal signs, like 5 is equal to 5. Notice that we use two equal signs to check if two values are equal. Don't forget, there are two. We can also compare other types of data. For example, we can compare floats. We can also compare strings. Or we can compare Booleans. These operators, which compare two values, are comparison operators. We can also combine Booleans for our third category of operators. For example, we can check if both Booleans are true using AND. Or check if either Boolean is true using OR. We can also flip a Boolean from true to false, or vice versa, using not true to turn into false. Let's combine these new operators with the comparisons we made above. For example, we can check if a number is within a certain range. Let's say we have the number 3, and we want to check if 3 lies in the range 2 to 10. We would check first if 2 is less than 3, and compare if 3 is less than 10. Python evaluates this expression. 2 is less than 3 is true, 3 is less than 10 is true. Since both are true, the entire expression evaluates to true. The interpreter then returns true. These operators, which allow us to combine Booleans, are called Boolean operators. And those are the key operators in Python to be aware of. Using operators and expressions, we can now perform arithmetic, compare data, and combine Booleans. Before ending the lesson, here's a quick tip. Quotes always denote a string. This is a common misconception and an easy piece of code to confuse. Let me show you why that's confusing. What does the following code output, do you think? Remember from above, if there are quotes, the data type is always string. When we add strings, we concatenate them. So once we hit enter, this gives us the combined string 123. Now if I drop the quotes, then we get the expected behavior. This gives us 246. So remember that. Quotes always mean the string data type. Let's recap what we've learned so far. There are 4 data types. Integers and floats are both numbers. A string is text. A Boolean is true or false with capital T and capital F. We can combine data and operators to get expressions, like 5 minus 2 or 5 less than 10. And finally, there are 3 types of operators that we covered: arithmetic operators like add and subtract, comparison operators like less than or equal to, Boolean operators like AND or OR. I know this is a lot of information at once. However, there's absolutely no need to memorize. For example, I will likely never say comparison operator ever again. I'll just say less than. I introduce these terms just to stay organized and familiarize you with what code looks like and what talking about code sounds like. So when you hear words like Boolean, float, or operator, the words aren't new to you. We'll practice some more in future lessons, so we'll build familiarity together lesson by lesson. If you'd like to access and download these slides, visit this URL. And good work! That's your very first pieces of code. We looked at the building blocks of code called expressions. In the next interactive lesson, we'll talk about what to do if we want to store data. In the next interactive lesson specifically, we'll solve this with variables. Let's talk about variables. If you remember variables from math class, they're basically the same thing. A variable stores data, and we'll see what that means by actually creating some variables. Specifically, here's how to define a variable. Notice that define is in italics and colored turquoise. This is intentional. Throughout this class, Any text that is italicized and colored turquoise like this is a special term that has a special meaning. In coder speak, we specifically say we define variables and assign them values. Let's now define the variable x and assign it the value 5. X in blue is the variable name, equals in black is the assignment operator, 5 in orange is the value. Let's try this now. In your editor, in the bottom half, we have the interpreter. In the interpreter, we'll define the variable x and assign it the value 5. Like before, the spaces here are optional. I've added them just to make the code more readable. Just like before, however, I would suggest you copy these spaces too to practice writing readable code. Hit enter. Notice there's no return value when you assign a variable. This is normal. Now, you can confirm the value of the variable x by simply typing in x. This gives me 5. Python read the input, evaluated the variable x, found its value, and returned the variable's value, which is 5. Now, let's try customizing this variable name. Here's how to pick a valid variable name. Your variable name could be an A. It could be a Z. It could even be nyan_cat. There are many possibilities. In fact, your variable name can contain any number of letters, numbers, and underscores. No other characters are allowed. So no periods, no spaces, and no dashes. Additionally, your variable name can't start with a number, but it can contain a number. So 3 nyan_cat is an invalid variable name, but nyan_cat3 is valid. Nyan.cat is invalid, but nyan_cat is valid. Let's try this now. Nyan_cat3 is a valid variable name. No news is good news here. The code executed without errors since the variable name is valid. However, 3 nyan_cat is an invalid variable name. Notice we get a syntax error. 3 nyan_cat is an invalid variable name because it starts with a number. Let's see another variable name, nyan.cat. Again, this is an invalid variable name. We get a different error this time, but for now, ignore those details. We'll see later why and what this error means. In this case, nyan.cat contained a dot, which is an illegal character. The only punctuation we can use in variable names is the underscore, like nyan_cat is equal to 5. And again, no news is good news. So far, we've assigned every variable to the value 5, though. Let's see what other values our variable can take on. Let's now see how to change the variable's value. A value can be any of the numbers we saw before, like 7. The value can also be an expression, like the orange 3 plus 6 here. To reiterate, we can change the variable name, the blue part, and we can change the value, the orange part. Anything colored black in these visualizations is fixed, like the equal sign here. Let's try this now. Let's now define the variable x and assign it to an expression, x equals to 3 plus 6. Hit enter. Like in our slide, the expression is 3 plus 6. If we now check the value of x, hit enter, we can see the value is 9 as expected. We can also assign to any other data types, such as a float, x equals to 3.14, or a string, like hello, or a boolean, like false. These are all valid values for a variable. Now, how do we use variables? Let's say we wrote 6 plus 2. We know Python will return 8. However, this time, since x equals to 6, we can replace 6 with x. Just like before, this expression will return 8. Let's try it. Let's assign a variable x to 6. Notice the terminology. Assign x to 6, assign y to 10, assign z to false. We always say assign a variable name to a value. You should use this terminology too. Now, double check x is equal to 6. Type in x, hit enter, looks good. Let's now use the variable x in an expression. Following our slide on the left, we write x plus 2. And this returns 8, as we expected. Now here's a tip. If you get a name error, this means you have a typo in the variable name. For example, we have not yet defined the variable u. So if I input u, the interpreter evaluates u, can't find the variable, and raises a name error. Again, I'm using the word raises an error deliberately. So far, we've learned that the interpreter can either return a value or raise an error. Now that we've defined variables, let's actually see one tip that I have for you. What do you think this line of code does? X equals to x plus 1. Don't hit enter yet. Here's the expression we saw in our interpreter on the right. Since we know x is now 6, let's plug that in. This gives us 6 plus 1, and the right-hand side is now equal to 7. Notice that x's previous value was 6. Now, x's value is 7. So in other words, the expression x equals to x plus 1 increments a variable value by 1. Now let's see what this value does, this expression does. Hit enter, and now we can check the value of x. Indeed, x is 7. Long story short, the line x equals to x plus 1 incremented the value of x by 1. Let's see the same concept applied to strings. Let's assign a new variable to a string value. Text equals to hello. Now let's add a string. Text equals to text plus world. If we now check the value of the variable text, we'll see hello world. In this way, we can continuously add text to this variable. As a recap, you've covered how to define variables. You've also covered what makes a valid variable name. Variable names can only contain numbers, letters, and underscores. You've also seen different examples of variable definitions throughout the lesson. If you'd like to access and download these slides, visit this URL. And good work! This was again a lot of concepts, and it's okay to feel overwhelmed at this point. You don't need to memorize everything. We're going to repeatedly use these concepts, and by coding repeatedly in the next few lessons, you'll incrementally get an intuition for right and wrong code. We now know how to assign a single expression to a variable. What if we want to modify this value somehow? In the next lesson, we'll cover a concept called functions, which will enable us to modify values. Welcome to bonus content for Lesson 3, Guided Exercises. In this video, we'll walk through exercises covering concepts from the last lesson. There are 3 steps. Number 1, I will present an exercise. Number 2, you should pause the video and try the exercise on your own. Number 3, after you've made an attempt, play the video and I will walk you through the solution. The goal is to make you comfortable with using these coding concepts and hearing the terminology. Some exercises will start with practice, which means we're covering a concept that previous exercises have not yet covered. All concepts will come from the previous video. The next few exercises after practice will then be prefixed with quiz. This means the previous exercise already covered the same concepts. You should try these quiz exercises as a test of your knowledge. Let's hop right in. Just like before, start by navigating to repl.it/languages/python3. Alright, let's start off with question number 1. This is a practice question. Output 9 in the interpreter using only the number 3 and any math operations you want. Give it a minute to try. And here's a solution, or here's one solution. I'm going to type in 3 times 3. Question number 2. This is now a quiz question. Output the number 5 in the interpreter using only the number 3 and any math operations that you want. Give it a try. And now here is a possible solution. I'm going to type in 3 plus 3 minus 3 divided by 3. Right? So this will give us 1, this will give us 6, and we have 6 minus 1 is equal to 5. Question number 3. We now have a practice question. Define a variable called x with the value 8. Give it a try. And here we have the solution, x is equal to 8. Question number 4. Define a variable called y with the value 3. Give it a try. And the solution here is y is equal to 3. Again, these spaces are optional. These are just the convention that I've been following. Question number 5. Practice. Define a variable called z with the value 5 using the variables x and y instead of the number 5. So remember here, x is 8, y is 3. Give it a try. All right, and here's the solution. We're going to now type in z is equal to x minus y. We're going to double check that z has the value 5, and indeed it does. Question number 6. This is now a quiz question. Define a variable called a with the value 11 using the variables x and y instead of the number 11. Again, x is 8, y is 3. Give it a shot. And now we have the solution. A is equal to x plus y. Double check that a has the value 11. Question number 7. Practice. Define a variable sound containing the string cluck. Give it a try. And now we have sound is equal to cluck. Here I'm using double quotes. You can also use single quotes for your string. In this particular question, it doesn't really matter which one you use. Let's go ahead and move on to question number 8. This is now a quiz question. Define the variable sound containing the string moo. I'm going to type in sound is equal to moo and hit enter. Let's go ahead and move on to the next question. Question number 9. This is now a practice question. Define a variable containing the exact string denoted here in red. Remember, you can use double quotes or single quotes to denote a string. In this case, the string contains a double quote. Give it a try. And here's the solution. Because the string contains a double quote, you'll have to denote the string using single quotes. So let's go ahead and define the string using single quotes. Again, this doesn't say what the variable name should be, so I'm going to call the variable name quote is equal to, and she said, yum. Add a single quote at the very, very end. Go ahead and hit enter, and there is our quote string. Now here I'm going to click on clear in the top right. You don't have to do the same, but if you do, make sure to click back into the window and hit enter so that you see the orange caret once more. Question number 10. This is now a quiz question. Define a variable containing the exact text denoted here in red. Give it a try. And here's the solution. I'm going to type in now a variable quote is equal to, and because the string contains double quotes, I will use single quotes to denote my string. And I said, comma, you. Perfect. Hit enter, and there is our string. Question number 11. Let's go ahead and define a variable containing the exact text denoted here in red. Here's a curveball though. The string contains a single quote now. Give it a shot. And here's the solution. Because the string contains a single quote, we actually need to denote the string using a double quote now, the reverse of what we did before. Type in quote is equal to double quote, and then merp. Add a double quote. And there is our variable. Question number 12. Here's another practice question. Define a variable b that is true if x is 8. Give it a shot. And here's now the solution. B is equal to x is equal to 8. Recall that to check equality, we use two equal signs. Go ahead and type in or hit enter. And to double check that this worked, we're going to check that b has the value true because x is 8. And it is indeed true. Question number 13. Define a variable c that is true if x is greater than 5. Type in c is equal, oopsie, give it a shot. Now here's the solution. C is equal to x is greater than 5. Hit enter, and because x is 8, x is indeed greater than 5, double check that c is actually equal to true. And indeed it is. Question number 14. Practice. Define a variable d that is true if the variable sound is moo. Give it a shot. And here's the solution. D is equal to sound is equal to moo. And hit enter. We're going to double check that D has the value true because sound is indeed equal to moo. There we go. Question number 15. Here's now a quiz question. Define a variable e that is true if the variable sound is yuck. Give it a shot. And now we have e is equal to sound is equal to yuck. Because we know that sound is equal to moo, e should be false. Type in e and hit enter, and that is now false. Question number 16. This is now a practice question. Define a variable f that is true if x is 8 and if sound is yuck. Give it a shot. And here is now the solution. We have f is equal to x is 8 and sound is yuck. Hit enter, and because we know that x is 8, this first part of the statement is true. However, sound is moo, so this second part of the statement is not true. Therefore, this entire statement should be false. Go ahead and type in f, and it is indeed false. Question number 17, this is now a quiz question. Define a variable g that is true if x is 5 and the sound is moo. Give it a try. And here's now the solution. You don't have to do the same, but I've clicked clear in the top right. If you do the same, make sure to click into the window, hit enter, and there we go. Let's go ahead and type out now the solution. G is equal to x is equal to 5, and sound is equal to moo. Here we know that x is in fact 8 and not 5, so this first part will be false, making the entire statement false. Go ahead and type in G, enter, and it is indeed false. Now for a quick temperature check. How are you doing? If this was doable, that's great. If this was barely doable, as in you got half the questions correct or more than a third, that's also great. As we progress, you'll hear more of these terms and concepts repeated again and again and again. That's how you'll build familiarity. That's how you'll build familiarity. We're looking for familiarity, not an A+. Number 3, if this wasn't doable, as in you only got 1 or 2 correct with the 17, no worries. Believe me, I know what that's like. I suggest doing this walkthrough again or rewatching the previous video. You can do it. Regardless of where you are, mastery is when you can come up with your own questions. If you feel you've mastered this lesson, try to come up with a few extra questions and solutions. Leave them in the discussion section of the class, and your fellow students will thank you for the extra practice. That's it for Lesson 3's guided exercises. In this lesson, you'll work with a coding concept called functions. This will pave the way for us to start our first nifty tools. Start by navigating to pytwiddle.com. First, what is a function? Think of the functions you learned in math class from grade school. At a very high level, a function turns input into output. This isn't completely precise, but for our purposes in this class, this definition is correct enough. Here's the definition illustrated. Functions accept some input value and return some output value. For example, consider the square function. Take in a number and return the square of that number. Here we take 3 as an input and return 3 squared, or 9. Here's another example, the absolute value function. It takes in the value -5 and returns the absolute value +5. Let's see one more. Here's a round function. It takes in a single float argument, 4.35, and returns the rounded version of that number, 4, an integer. So you now have a rough idea of what a function is by example. A function is a piece of code that takes an input and somehow transforms it into output. Now that we know what a function is, let's now see how do we use a function. To be specific, how do we call a function? Again, call is a special word. In coder speak, we generally say that we call, not use functions. Consider the absolute value function again. In Python, the function's name is just abs. Use parentheses to call the function. As a side note, calling the function means we execute the function. In between the parentheses, add any inputs that the function needs. We also refer to the input as an input argument, or just the argument. In summary, we call the function abs with one argument, 5. Let's try this. Again, the bottom half of your editor is an interpreter. In that interpreter, we'll now call the function abs with the argument -5. Python evaluates, then returns the absolute value of -5, which is +5. Let's try this on one more value. We can also pass in floats. For example, abs of -3.14 also gives us +3.14. Let's see more examples of functions to build familiarity with this format and terminology. Here is the round function. This function takes one argument and outputs the rounded number. To call the function, add parentheses and the argument. And there we go. We call the function round with one argument 1.2. Let's try this too. Let's call the function round with the argument 1.2. We input round of 1.2, Python evaluates, then returns the rounded value, which is 1. We can also call round on our favorite number, 3.14. As expected, Python returns the rounded integer 3. Let's see one other function as an example. Again, there's no need to memorize these functions. This is just to practice reading, writing, and talking about code. Consider the function max. This function accepts 2 input arguments and returns the larger of the 2. To call the function max, again add parentheses and arguments. When there are multiple arguments, we separate arguments using commas, like this. And that's it. We call the function max with 2 arguments 5 and 7. Let's try this in code now. Let's call the function max with the arguments 5 and 7. We input max of 5 and 7, and like usual, the space after the commas for readability. Python evaluates, then returns the larger of the 2 values, which is 7. Speaking of multiple arguments, some functions have optional arguments, like round. Round optionally takes in a second argument, which corresponds to the number of digits to round to. For example, we can write the following to round pi to 2 digits. To reiterate, the first argument is the number to round, and the second argument is the number of digits to round to. This gives us 3.14, which is rounded to 2 digits. Let's now expand the set of possible functions by learning how to import functions that other coders have written. There are 2 ways to import functions in Python. For simplicity, I'm just going to teach you one. Simply write from library import function. A library is a collection of Python code that someone else has written that we can use. And the function that's imported is just like any other function we've been using. Let's see what that looks like and how to use one of these functions. Let's import a function that can report the current time. From time, import time. The first time is a library. The second time is the function name. Hit enter, and let's now call our time function. Notice this gives us a fairly large number. This is actually number of seconds since January 1st, 1970. We can call time again and again. And you can see that each time we call it, the returned value keeps increasing, although by small amounts. Let's use the code we've learned so far to compute the number of years since January 1st, 1970. First, note that calling a function is a valid expression too. It's just different from the other expressions we've seen before. As a result, just like any other expression, we can assign the returned value to a variable. Let's define a variable called seconds, and we'll assign it to the value returned by the function time. Remember, we use == for defining variables. This is a lot to unpack. On the right-hand side of the equal sign, we call the function time, just like we did above. On the left-hand side, we have the variable name, and the equal sign tells us that this is a variable assignment. Hit enter, and now the seconds variable contains the number of seconds since January 1st, 1970. Let's see its value. Type in seconds and hit enter. Now we can see a very large number, just like the very large numbers we saw before. Now, we can use this seconds variable to compute the number of years since January 1st, 1970. First, we know that there are 60 seconds in a minute. So to get the number of minutes, we can just divide seconds by 60. In the same vein, we know there are 60 minutes in an hour. So to get the number of hours, we can divide minutes by 60 as well. We can then divide hours by 24 to get the number of days. And we can divide days by 365 to get the number of years. Finally, let's check how many years it's been. Type in years, hit enter, and 54 years. This makes sense. It's currently 2024, so 1970 was indeed 54 years ago. To recap, we learned how to call a function. To call a function, use the function name, parentheses, and arguments. If there are multiple arguments, we separate arguments using commas. We can also import functions to expand the number of functions at our disposal. If you'd like to access and download these slides or view completed code for the example in this lesson, visit this URL. You can now modify data in more interesting ways, and even more importantly, you can now use what we've learned, calling functions, to make programs that ask the user for their input, which we'll see shortly. To close out our lesson, we'll now cover a few bonus topics. I suggest skipping bonus sections for your first time through the course, or if this is your first exposure to code. Not because the concepts are particularly advanced, but because I'm going to go through extra content pretty quickly, and you don't need these concepts to grasp core coding fundamentals. If the lesson is feeling a little slow, or if this is your second time through the course, this bonus section is for you. So far, we've called functions using positional arguments. Positional just means that the meaning of the argument depends on its position. For example, the first argument to round is the value to round. However, we can also identify this argument explicitly using its name. According to Python documentation, this first argument is called number, so we can equivalently write round of number is equal to 3.14. When your function has many arguments, keyword arguments can be very helpful in making code more readable. For example, as we said before, round has a second optional argument that tells us how many digits to round to. So we can also write round 3.141592, comma, 2. This rounds our number to the nearest 2 digits. To make this code clearer, we can also write round number equals to 3.1592 and n digits equals to 2. And this now tells us what the meaning of each of these values is. We can mix positional and keyword arguments as well. For example, we can write round of 3.1415 and digits equals to 2. However, note that keyword arguments, meaning n digits equals to 2, can only come after positional arguments. So let's see what happens if we switch that around. Round of n digits equals to 2, 3.1415. Hit enter, and this gives us a syntax error. It tells us exactly what's wrong. Positional argument, which was 3.1415, follows keyword argument, which is n digits equals to 2. So let's see what happens though if all of your arguments are keyword arguments. If that's true, you can mix and match ordering for keyword arguments willy-nilly. So round n digits equals to 2, number equals to 3.1415. And this is also true if you have more keyword arguments. You can simply interchange the order however you see fit. And that's it for keyword arguments in Python. This wraps up calling functions. On to the next lesson. In this lesson, we'll write a nifty tool that converts between currencies. Just like before, navigate to pytwiddle.com. In the bottom half of pytwiddle, you'll see an interpreter. Let's start by writing code in this interpreter. Call the input function with one string argument. We haven't seen the input function before, so we'll see now what it does. Here, my string argument will ask for the amount of Japanese yen, followed by a colon. Don't hit enter yet. Assign the returned value to a variable named response. And now hit enter. You will now see 𝐥𝐞𝐬𝐭 which is exactly what we inputted for the argument here. Notice as well that the interpreter's 3 arrows are now missing. This means your program is asking for input, not the interpreter. Type in 1000 and hit enter. Nothing much interesting happens, it seems. However, your program is finished, and the interpreter's 3 arrows have returned. Well, where did the text go? Quite simply, the input function returned the 1000 text that we inputted, and we assigned that string to the variable response. As we mentioned before, variable assignment has no return value, which is why we don't see additional output. Let's now see what the value of response is. Type in response and hit enter. We see the 1000 we inputted earlier. Now, our variable contains user inputted information. This is great. We can now write programs that ask the user for input. However, do you see the single quotes around our 1000? Remember that quotes always mean a string. However, we want an integer so that we can do math to convert currencies. So we have a string, but we need an integer. Notice that we're running some quick tests in the interpreter, by the way, for some explanation first. I suggest that you always do the same when you're building programs. you can run quick tests in the interpreter to check if some code is valid. To start, let's see how to convert this stringified integer, into an integer. We can use the built-in function int to extract the number from that string. Let's try that now. Int of response. Hit enter, and that gives us the number 1000 now. There's no quote here, so this is truly an integer and not a stringified integer. Now we can perform arithmetic on that number. So int of response plus 1. This now gives us 1001 as expected. Make sure that your plus 1 is outside of the parentheses if you hit an error. Up to this point, we've been working in the Python interpreter. We type one line of code and the interpreter immediately evaluates that line of code and returns the results. This is the interpreter on the bottom half of the screen that we've been using. Now we're instead going to write code in a file. This is the top half of the editor. We use this file editor slightly differently. We won't run code line by line anymore. Instead, after writing all code, we'll then run the file by clicking on the Run button in the top left. Here in this file, we will write a program that converts Japanese yen into US dollars. Let's ask for the user's input, just like before. Input will ask for 𝐁𝐞𝐬𝐭. Then assign the returned value to a variable called text. Now, since we're writing code in the file editor, we need to tell Python when to output and what to output. To do so, we'll use the print function. Any argument we provide to the print function will be outputted. Let's call print on the variable text. Now click Run in the top left to make sure the program so far works. Our program is now asking for input. Input any number of your choice. I'll type in 1000 and hit enter. If you enter in a decimal value, your program will result in an error, so make sure to input an integer. Let's now update our program to convert the stringified integer into a proper integer. Delete print of text, and now we can write 𝐺PY equals to int of text. When writing programs generally, check your program as you build it incrementally. Don't build the entire program and run it once at the end. Let's practice this now. Output the variable 𝐺PY to make sure it's converted into an integer successfully. Print of 𝐺PY. Hit run in the top left. Your program prompts, input 1000 to test, and your program should print the same number you inputted with no quotes. Perfect, your program works. Now we can divide by the conversion from Japanese yen to US dollars. According to Google, $1 US is equivalent to 155.68 yen as of the time of this video. So we divide by that. Delete print, and now USD is equal to 𝐺PY divided by 155.68. Next, we need to round to 2 decimal values, since we can't have fractional pennies in US currency. Luckily for us, as we discussed earlier, the round function actually takes a second argument, which tells us how many decimal values to round to. So USD is equal to round USD of 2. Now we output the amount in US dollars. Click on the Run button in the top left to run your program. Once your program prompts you for the amount in yen, type in an integer. I see a delicious unagi-don for 3,000 yen. Let's see how much that is in US dollars. Type 3,000, hit enter, and $19. That's pretty good. Now you're set for your next trip to Japan. Naturally, you could use any existing calculator for this, or do quick mental math if you're into that. However, what if we had a program that could do more? Maybe it could show you conversions in multiple currencies, for example. Then that's a program that's saving you time. That's it for our tool. On to the next lesson. In this lesson, you'll learn about a concept very similar to functions, called methods. This will expand the set of tools we can build. Start by navigating to pytwiddle.com. What is a method? At a very high level, a method is an object-specific function. Here's an example. Conceptually, let's say we have a car object. Don't worry about what the code looks like for now. This car may have a few controls you'd expect, like accelerate or brake. Or maybe you have a dog object. This dog may have a bark or rollover feature. A file may have a read or write feature. These are all examples of methods because they're object-specific functions. So how do I call a method? First, you need an object. Here we have a string object. Next, add a dot. This dot means we're about to access a method for this string object. Add the method name. In this case, the name is count. We'll explain what count does in a second. To call this method, just like you call functions, add parentheses. Then, add your single argument, a. All in all, the count method will tell us how many times the substring a appears in the original string ab. Let's summarize the parts. From left to right, we need the object, which is a string in this case, a period, the method name, and the input arguments. Since we use a dot to call a method, we call this dot notation. Let's try this in code now. Again, in our interpreter on the bottom half of the editor, we'll now use the exact example from the slides. We'll count the number of a's there are in the string ab. To do this, use the method called count on the string ab. And give it a single argument a. This is slightly less interesting. A obviously only occurs once. So let's do a more interesting example. How many s's are there in Mississippi? Mississippi dot count of s. Looks like there are 4. We can now use the count method to count the number of characters in a string. Let's see another example. To build familiarity with this format and terminology, we're going to now talk about a different method. This method, uppercases all the characters in a string. It takes no arguments. Let's try it. We'll uppercase a string by calling the upper method on ABC. We can also use upper on longer strings too, at the top of my lungs. Dot upper. Strings have other methods too. For example, we can do the opposite and lowercase all letters using the lower method. We can also check if a string contains a valid integer using the isDigit method. abc.isDigit. Since this is not a valid number, this should give us false, as expected. Let's try this on a real stringified integer, 1 for example. isDigit now gives us true, as expected. Now let's see a more practical example where we read a web page. From requests, import get. Requests is the library name. Get is the function name. Let's try a page that I set up just for you. Hit enter, and now type in get on the following web page: https:/coding101/Pikachu. And don't forget that trailing slash right here, and also don't forget HTTPS. Don't hit enter yet. This, in theory, this get call will open the web page and load its contents. Let's assign the fetched contents to a variable named response. Hit enter now. Here you may see a warning, but you can ignore this warning about unverified HTTPS request for now. Now let's see what was fetched. Type in response and hit enter. Now this is a data type we haven't seen before. It's a response object. If you look at any Hello World tutorial for using the requests library, you'll find that we need to access an attribute of the response object. To access the attribute for any object, use dot notation as well. Write the object, which is here in orange, add a dot in black, then write the attribute name, which is here in blue. Notice that there are no parentheses. Let's try this. Let's see what the text attribute contains. Response.text. And this doesn't look like a whole lot. However, notice that there are line breaks here, this \n. So we need to print this text for these lines to render correctly. Type in print of response.text and hit enter. And there you go. There is a Pikachu. Here's a quick recap of what we covered. We now know how to call methods on any object using the method name, parentheses, and arguments if needed. Let's recap both functions and methods since they're so similar. We call functions just using the function name. Call using parentheses without the dot, like abs of -5. When we call methods, we do need dot notation, like variable.upper. If you'd like to access and download these slides or view completed code for the example in this lesson, visit this URL. And you can now perform advanced data modifications by calling methods. Time for some bonus content. As usual, I suggest skipping these on your first time through the course. In this bonus section, we'll talk about how to read and write files. The reason why this exists as a bonus section is because there's a caveat. If you're using an online editor like PyTwiddle or Replit, your files aren't guaranteed to persist. Any file you create today may not exist tomorrow. However, if you're running code locally on your own computer, those files will of course persist until you delete them. So that's the caveat. Fortunately, the code itself doesn't require any new concepts. Let's hop right in. With this bonus lesson, we'll create, write to, and read from a file. We won't actually read and write files in this course, so this is just for practice. Let's create a new file. To do this, we need to open a file in write mode. Type in open. The first argument here is going to be the path to the file. For us, it's going to be test.txt. The second argument is the mode. In this case, we're going to open this file in write mode. If the file does not yet exist, this function call, open with the write mode, will create the file. Let's assign this open function's return value to a variable called file. Let's see what the variable file contains. It's some gibberish. This return value is a data type we again haven't seen before. This is called a file handler. Since we opened the file in write mode, we can write content to the file handler. To write, we'll use a write method using dot notation. Write takes one argument, which is the content to write to the file. In this case, hello world. This returns 11, which is the number of bytes that have been written to the file. Now, since we didn't open in read mode, we can't read from the file though. Let's try anyways by calling the read method. Notice the error. The file is not readable. This is because we opened the file in the wrong mode if we want to read. As a result, let's close the current file handler. This will ensure that our write command earlier takes effect. File.close. Next, we need to create a new file handler for reading. File is equal to open test.txt. Again, the first argument is the path. The second argument is the mode. In this case, we're using R for the read mode. Now, let's try reading from the file by calling its read method. Just like the other methods, we'll use dot notation. Hit enter, and notice we get the string that we wrote, hello world. And that's it for our brief introduction to reading and writing files. We won't use these methods in this course, so this was really, again, just to practice calling and using methods. And that's it. On to the next lesson. In this lesson, we'll build another nifty tool. This tool will reformat a list of comma-separated emails for us into one email per line. It will also count the number of email addresses. Just like in the previous lesson for nifty tools, we're instead going to write code in a file. This is the top half of the editor. Remember that after writing all code in the file editor, then we run the file by clicking on the run button in the top left. Call the input function again. This time, you'll prompt the user for a list of comma-separated emails. Assign the returned value to a variable named text. And now our variable text contains user inputted data. Now we want to replace all commas with line breaks. Fortunately, there's a method for the string object called replace. In coder speak, we would equivalently say there's a string method called replace. You'll hear me say this inadvertently every so often. There's a string method called upper, a file method called write, a string method called replace. Let's now write text.replace. Replace takes two arguments. The first argument is the character to replace, so the comma. And the second argument is the argument to replace it with, the string to replace it with, which is \n, line break. Replace performs the replacement on all commas, then returns the new modified string. Let's assign that returned modified string to the same variable text. In this way, our variable text now contains the new string, where we have one email per line. Let's see what our new string looks like. Call print on the variable text. Click run in the top left to run your program, And now type in several emails. Here we'll type in a@b.com, b@c.com, and c@d.com. Hit enter, and you should now see each email address on its own line. Our file works. We're going to add one more line of code, counting the number of email addresses there are. To do this, we use a string method called count. Count takes one string argument, and count returns the number of times that argument shows up. For example, we can count the number of email addresses by counting the number of times the @ symbol occurs. Here we'll write text.count @. Assign this to a variable called count. This will give us the number of email addresses in our string. Now make sure to output this count by calling print on it. Hit run in the top left to run the program, and you should now see the count at the bottom after the emails. So b@c.com, and again c@d.com. And there we go. We have all of our emails and the count 3. And that's it for this nifty tool. On to the next lesson. In this lesson, you'll create your first collections of data. In particular, we'll create a list of data. Start by navigating to pytwiddle.com. A list is what the name implies, a collection of ordered items like 1, 2, 3. Let's start by defining a list. Like earlier, define is a special word. Previously, we defined variables. Now, we're going to define a list. To define a list, we always use square brackets, one to start the list and one to end the list. We also use commas to separate each item in the list. In this case, our items are numbers. Our items can also be strings. Our items can also be booleans, or some combination of all those data types. Let's try out these examples in code now. Let's start from the interpreter again, in the bottom half of your pytwiddle editor. In the interpreter, create a list of numbers. As usual, spaces after the commas are for readability. Hit enter. We can also make a list of strings, or a list of booleans. We can also mix data types in a single list. Notice in each of these examples, I used square brackets and commas to separate each of the items. We can now define a variable names and assign it to our list of strings above. Names equals to the list of strings Jane, John, Alex. On the right-hand side of the equal sign, we have the list from before. Square brackets to define a list and commas to separate items. On the left, we have the variable name, and the equal sign is what tells us this is a variable assignment. Let's check the contents of this variable names. Hit enter. Perfect. This was the list we defined. However, what if we wanted to access different items in our list? How would we access the first item on our list of names, for example? Let's get an item from our list. Again, get is a special word. Generally, get means to access some part of a collection of data. So let's get an item. Look at the list of names we have. We assigned the variable names to a list. That list contains a few names, and we want the first name. To get this item, know which position this item is in. This item is in the first position. Next, find the index for the item you want. In most coding languages, the first item is actually at index 0. The second item is at index 1. The third item is at index 2, and so on and so forth. We call this zero indexing, meaning we start counting from 0. To summarize, we use index 0 to get the first item. Next, use the index and square brackets to get the item. This code returns the value at index 0, meaning the first value. Our first value is Jane, so this code returns Jane. Let's try this now. Follow the code on the left side exactly. Write the variable name for the list, which is names. Add square brackets and the index 0. Hit enter. And there we go, we have Jane. which is we can confirm the first item. Let's also see the second name. Use the variable name, names, square brackets, and index 1. Hit enter. And again, we can confirm John is the second item from our list. Finally, let's get the last name here, our third name. Names, square brackets of 2. And there we go, we have Alex. We know there are only 3 names in the list, so what if we tried to get the fourth name at index 2? Names of 3. Sorry, the fourth name at index 3. Hit enter. And see this index error right here. As you might guess, this means that our index 3 is invalid. After all, the list only has 3 items in it, so Python raises an error if we try to access the fourth. Right here in the interpreter, let's now explore a few methods that lists have that we can use to modify lists. The append method will add an item to the end of the list. Let's see it in action. Names.append. Append takes one argument, which is the value to add. In this case, we'll add a string, Amy. Append also does not return a value. Instead, it operates in place, meaning it modifies the list names and does not return a modified list. Let's now see what happened to names. And ta-da! Names now has 4 values. As we said, the list names was modified in place. We can also use the pop method to remove an item from the end of the list, names.pop. If we don't pass any arguments here, pop by default will remove the last item. Hit enter. This time, names.pop does 2 things. First is it modifies the list in place by shortening it. Second, it actually returns the value it removed, which in this case is Amy. Let's now see what our list names looks like. And as promised, names now only has 3 items. Let's quickly recap what we learned. First, lists are ordered collections of items. Use square brackets to define a list. Use square brackets and the index to get an item from the list. And finally, indices start from 0, so the first item in the list is at index 0. As a brief addendum, we also covered 2 methods for lists: append, which adds items to the end of the list, and pop, which can remove items from the end of the list. If you'd like to access and download these slides, visit this URL. In this lesson, we created our first collections of data. In the next lesson, you'll learn about a different kind of data structure in Python. Let's now discuss some bonus concepts. These are common ways of using lists that you'd see in the wild. Like before, I recommend skipping bonus content if it's your first time through the course. Let's hop right in. Just like we can assign variables, you can also set items in a list to a value. For example, we can change the first item in the list to Jen. Names of 0 is equal to Jen. It looks like a lot to unpack, so let's work through it from left to right. Here, names of 0 means the first item in the list, and the equals operator assigns the first item in the list to the value on the right. Our value is a string, Jen. Hit enter. To double check that our assignment was successful, type names of 0. And there we go, we have Jen. As a recap, assignment operators don't have a return value, which is why we don't see any output here. You can also check which names are in the list by using the in operator. For example, to check if Jen is in the list, we can write Jen in names. This gives us true as expected. We can also check other values, Jane in names, and this gives us false as expected. Remember, we replaced Jane with Jen, so Jane is no longer in the list. We can double check that by checking what the variable names contains. And there we go. It has Jen, John, and Alex, no Jane. And that's it for this lesson's bonus content. On to the next lesson. In this lesson, we'll build a nifty tool that samples 2 names at random from a list of names. You could use this program to randomly pair up friends for a Secret Santa, for example. For this nifty tool, we'll start immediately in the file editor in the top half of 𝐵twiddle. From the library called random, import a function called choice. The choice function picks a random item from a list that we provided. Like before, call the input function with one string argument. This argument will prompt the user to input a list of names. Assign the return value to a variable named response. Next, call a string method called split. Split takes one string argument, which is the character to split on. We want to split the input string, response, on every comma, so our string argument is just a comma. This now gives us a list of all the names. Assign the list to a variable called names. Then, we'll finally call the choice function that we saw before. Specifically, call the choice function on the list names. This will sample a random name from the list of names and return that name. Assign the returned name to a variable called name. Finally, call the print function on the variable name to display the sampled name. To make sure that our program works so far, we're going to now hit run in the top left to see the program in action. The program will prompt you for names. We'll type in 3 here and hit enter. And there we go. We get one of the names sampled. We can also try running it again. John, Jane, Alex. And we get John again. Let's try this one more time and see if we can get a different name. John, Jane, Alex. There we go. So we now know that this program is sampling randomly. Now we need to sample a second name without replacement. Without replacement just means that we can't sample 2 of the same name. So we can't sample Jane twice, for example. One way to do this is to simply remove the first name we sampled from the pool of names, then resample. To remove an item from a list by value, use a list method called remove. Remove takes in a single argument, which is the value to remove from the list. This value can have any data type, so as long as the data type matches the value in the list, we're good to go. Let's now type in our file editor, names.remove. And we should give it one argument, name. This line break right here is optional, it's just for readability. And just like before, remove is for once a method that operates in place. This means that it removes an item from the list and it does not return a new list. As a result, there's no return value and we don't need to assign it to a variable. Now that we've removed the previously sampled value, we can now resample a new name. Follow the same convention as above and call the choice function, storing the return value in a variable called name. Finally, we'll call that print function on the variable name to display the second sampled name. Click Run in the top right to run your program. Type in a list of names. I will do John, Jane, Alex, and Amy. Hit Enter. And here we have 2 names sampled from our list. This now completes our nifty tool for sampling random names from a list. On to the next lesson. In this lesson, you'll learn about another collection called a dictionary. Start by navigating to 𝐵twiddle.com, which I've already done on the right-hand side here. A dictionary is a mapping from keys to values. Think of it like your dictionary at home, which maps words to definitions. Let's make this more concrete by seeing some code. Let's define a dictionary. To define a dictionary, we always use curly braces, one to start the dictionary and one to end the dictionary. We use a colon to separate the key from the value. Here, the key is a string, denoted using purple. The value is a number, denoted using pink. This dictionary maps the key Jane to the value 3. We use commas to separate entries in the dictionary. We're separating Jane, which maps to 3, from John, which maps to 2. Let's code this up. Again, inside of your interpreter in the bottom half of 𝐵twiddle, define a dictionary, just like what we have shown on the left. This is a dictionary, mapping names to numbers. Hit Enter. Now, let's assign a variable to our dictionary. Let's say the dictionary maps names to number of cookies, so I'll name the variable name to cookies. To make sure we define this variable correctly, we'll now type in name to cookies. And we get the same dictionary that we inputted. However, what if you want to know how many cookies Jane has? How would you get a specific value from the dictionary? Let's get an item from our dictionary. First, know the key for the data you want. In this case, we want Jane's number of cookies, so we need the key Jane. Second, using the key Jane and square brackets to get the item. Second, use the key Jane and square brackets to get the item. This code returns a number that Jane corresponds to, which is 3. Let's see this in action. First, write the variable name for the dictionary, which is name to cookies. Add square brackets, then the key. Hit enter, and this gives us the value corresponding to Jane, as we can see here. Let's do that again, but now for John. Write the variable name for the dictionary, and add square brackets, then the key John. Hit enter, and again, this gives us the value corresponding to John in our dictionary. Now what if we do the same for a name that doesn't exist? Let's try Bob. Hit enter, and this gives us a key error, meaning that the key Bob does not exist in the dictionary. If you ever see a key error out in the wild, you may have a typo in your key. Let's recap what we learned about dictionaries. We use curly braces to define a dictionary. We use brackets and the key to get items from a dictionary. Across the 2 collections that we've covered, we've used a lot of punctuation in this lesson. So let's quickly recap what is used for what using this cheat sheet here. First, in the previous lesson we covered lists, which are ordered collections of items. We define a list using square brackets. Then we get an item from a list using the index and square brackets. Second, we have dictionaries, which are mappings from keys to values. Define a dictionary using curly braces. Get an item from a dictionary using the key and square brackets. If you'd like to access and download these slides, visit this URL. You can now represent any data of your choosing with Python data collections. Let's now cover some bonus topics for dictionaries. Just like you can modify lists, you can also modify dictionaries. Here, for the key Jane, we can change the value from 3 to 10. Name to cookies of Jane is equal to 10. Hit enter. To check that our assignment was successful, we can get the value corresponding to Jane. And here we see 10. We can also output the entire dictionary name to cookies. Hitting enter returns the modified dictionary of cookie counts. Before, this was Jane 3, John 2. Now it's Jane 10, John 2. This is a cookie, but that's it. In this lesson, we'll build a nifty tool that reports your location. This tool specifically uses an identifier called an IP address. At a very rough level, an IP address reveals what city you're in. However, if you use a VPN, your location should default to a completely unrelated location. For example, if you use iCloud's VPN, your location might default as San Francisco, even if you're in Seattle, say. As a result, you could check your VPN is working using this tool. For this nifty tool, we'll start immediately in the file editor in the top half of PyTwiddle. Start by importing a function that opens web pages for us. Use a library called requests and its function called get. So we type here from requests import get. Using get, fetch the contents of a website called ipinfo.io. Here we call the function get on the string https ipinfo.io/json. Let's now assign the returned contents to a variable named response. Before proceeding, let's try running this code so far. Hit run in the top left. And we get a massive wall of red text. Here you can see that our red text ends in a connection error. It turns out that adblock will understandably block calls to this URL. Namely, any website that accesses this ipinfo.io can guess your location. However, in this case, we are the developers trying to access our own location, so you'll need to disable adblock temporarily for this function to work. So let me do that. I've now disabled adblock. Rerun by hitting run in the top left. Now we see a warning here, but no errors. So that means our web page fetch has worked. Next, call the response object's JSON method to get the web page's contents as a Python dictionary. Response.json. Assign the return value to a variable named data. By the way, I keep writing code in these two steps. First, write the right-hand side, then write the left-hand side. Just to make it extra clear to you what's going on. You don't need to write code in this way. In fact, since I don't usually write code in this way, I may skip these intermediate steps moving forward. Now, in this dictionary data, let's access the key city. Finally, just like in previous lessons, use the print function to display the city. Hit run on the top left to see which city your computer is accessing the internet from. And if VPN is activated, if VPN is working correctly. Here we get Seattle, which is where I'm currently in, but I don't have a VPN activated. That's it. Welcome to bonus content, lesson 4's guided exercises. In this video, we'll walk through exercises covering concepts from the last lesson. Again, there are 3 steps for each exercise. I will present an exercise, pause the video, and try the exercise. Then, I will walk you through the solution. Some exercises are practice, when the exercise is the first to cover a concept, and the other exercises are quizzes. You should try testing your knowledge with these. Let's hop right in. Navigate to repl.it/languages/python3. You'll see a page similar to the one on the right. I've minimized a few of the tabs so that you can only see the interpreter on the right-hand half of the screen. Now, let's go ahead and start off with question number 1. This is a practice question. Define a list with 3 numbers. Assign the list to a variable called numbers. Give it a minute to try. Now we can define numbers is equal to, and a list with 3 numbers, and I'm going to write 4, 5, and 2. Hit enter. We're going to type in numbers to check that our list was defined successfully. Hit enter, and there we go. Question number 2. This is now a quiz question. Define a list with the numbers 4, 2, and 7 in any order. Assign a list to a variable called numbers2. Give it a minute to try. And now here's the solution. Numbers2 is equal to 4, 2, 7. Again, don't forget your opening and closing square brackets. Now, question number 3. This is a quiz question. Define a list with the strings A, B, and C. Assign the list to a variable called strings. Give it a minute to try. And here's a solution. Type in strings is equal to a list of strings A, B, and C. Go ahead and hit enter. We're going to double check that this list was defined successfully, and indeed it was. Question number 4. Define a list with 1 boolean. Assign the list to a variable called booleans. As a hint, remember booleans are either true or false with capital T's and capital F's. Give it a minute to try. And here's the solution. We're going to define a list called booleans is equal to, and this list will only contain 1 boolean. In this case, we'll say true. Go ahead and hit enter. Once again, we'll check that this list was defined according to the way that we wanted, and there we go. Question number 5. We now want to get the first number in the list numbers. Give it a minute to try. And here's the solution. Go ahead and type in numbers, square bracket of 0. Right? Again, remember that 0 is the index of the first item. So this will fetch the first item in the list of numbers, which in this case is the number 4. So go ahead and hit enter, and there we have 4. Question number 6. This is now a quiz question. Get the third item in the list strings. Give it a minute to try. And now we have strings, and the third item in the list is at index 2. Remember, the first item is at index 0, the second item is at index 1, and the third item is at index 2. So go ahead and type in square bracket 2, enter, and there we get the third item in the list. Question number 7. This is now a practice question. Define a dictionary mapping strings to booleans. Assign Jack to false, Jane to true, and Alex to true. Assign the final dictionary that you get to a variable called name to hungry. Give it a minute to try. All right, and now we start off by defining the variable. So name to hungry is equal to. And now we're going to define the dictionary. Dictionaries are denoted by a curly brace, and we'll now type in the key, which is Jack, and the value, which is false. Then the key is Jane, and the value is false. The final key here is Alex, and the value is true. Go ahead and add that curly brace. So you'll notice that in this interpreter, the line is wrapped around. If your interpreter is wider than this, or if your screen is wider than this, then you won't see this line wrap around. I didn't hit enter or create a line break. This interpreter wrapped around on its own. Go ahead and hit enter. And we want to double check that this dictionary has what we want. So type in name to hungry, and that is the dictionary that we indeed want. Go ahead, and I'm going to hit clear in the top right. You don't have to do this, but if you do, click into your window and make sure to hit enter so that you see this orange caret once more. Question number 8. Define a dictionary mapping names to numbers. Assign these keys to these numbers, and assign the final dictionary to a variable called names to burgers. Take a minute to try this question. Now here's the solution. We're going to define the variable name to burgers is equal to, and here we have a dictionary denoted with a curly brace. We're going to assign the string Emily to 1, the string Jenny to the number 2, the string Neil to the value 3. Go ahead and end this with another curly brace. Hit enter, and we're going to double check this dictionary. And there we go. We have what we want. Question number 9. Here's another practice question. Define a dictionary mapping strings to strings. Assign the dictionary to a variable called names to names. Go ahead and give it a minute. And here's the solution. Go ahead and type out names to names is equal to, and we're going to say Jack to Emily, and then Jenny to Neil, and Alex to Bob. Go ahead and hit enter, and there's our dictionary mapping names to names. Question number 10. This is now a quiz question. Define a dictionary mapping numbers to strings. Assign the dictionary to a variable called age to name. Give it a minute to try. And here's the solution. We're going to type out age to name is equal to, and dictionary with a curly brace, and we're going to come up with arbitrary numbers to strings. Here we're going to say 14 to Bob. We're going to say 15 to Alex, and let's say 20 to Jenny. Go ahead and hit enter, and there's our dictionary. Question number 10. This is now another practice question. Fetch the Boolean corresponding to Jack in the dictionary name to hungry. Give it a minute to try. And here's the solution. Name to hungry, and we want the value corresponding to the key Jack. So we're going to add a square bracket and type in the key. And as we'd expect from the previous set of questions, the value is false. Now, question number 12. This is a quiz question. Fetch number of burgers corresponding to Neil in the dictionary name to burgers. Give it a minute to try. All right, now let's type out the solution name to burgers, and burgers, and the key is Neil. So we're going to type in Neil and hit enter, and there we get 3. Question number 13. This is now a practice question. Define a list of dictionaries. Go ahead and give it a shot. Now let's go ahead and type out the solution. Here we're going to have the variable name list to dictionary. List of dictionaries. And here we're going to define a dictionary. We'll say A to 1. Because I'm lazy, it's only going to have one key and one value, and we're going to have just a second dictionary in this list. Go ahead and hit enter. And again, you can create whatever dictionaries you want with whatever keys and values you want. Go ahead and now move on to the next question. Question 14. Here is a quiz question. Define a dictionary mapping strings to lists. Give it a minute to try. And here is a possible solution. We're going to define a dictionary. Oops, let's say string to list is equal to a dictionary mapping a string, let's say Jack, to a list of numbers. And I'm going to be lazy here and just add one key and one value. Go ahead and hit enter, and there we go, string to list. And once again, let's start off with a temperature check. How are you doing? If this was doable, that's great. If this was barely doable, don't worry. Keep going and you'll build familiarity as we go. Finally, if this wasn't doable, that's also okay. Watch this video and the previous one again. Each time you rewatch, the concept will sink in a little bit more. If you have any questions, definitely don't hesitate to leave a question in the discussion section in the class. If you feel you've mastered this lesson, try to come up with a few extra questions and solutions. Again, leave them in the discussion section of the class and your fellow students will thank you for the extra practice. That's it for Lesson 4's guided exercises. To bonus content, Lesson 5's guided exercises. In this video, we'll walk through exercises covering concepts from the last lesson. Again, there are 3 steps for each exercises. 1, I will present an exercise. 2, pause the video and try the exercise. 3, I will walk you through the solution. Some exercises are practice when the exercise is the first to cover a concept, and the other exercises are quizzes. You should try testing your knowledge with these. Let's hop right in. Navigate to repl.it/languages/python3. You should then see a page like the one on the right. I have split my screen so that you can see the questions on the left-hand side and the interpreter on the right-hand side. Question number 1. This is practice. A function min returns the smaller of 2 numbers. Call min with 2 numbers as input arguments. Give it a try. And here's now the solution. Min, and I will put in 2 arbitrary numbers, 2 and 6. Question number 2. This is a quiz. A function max returns the larger of 2 numbers. Call max with 2 numbers as input arguments. Give it a try. And here's now the solution. We have max, and I'm going to type in the 2 same numbers. And there we go. Question number 3. This is again practice. A function sum returns the sum of a list of numbers. Call sum with a list of numbers as input. Give it a try. And here is now a solution. Sum, add a parentheses to call the function, and then add a square bracket to denote your list. I'm going to pass in a bunch of random numbers. Here I'm going to type in 4, 8, and 6. I'm going to close the list with a square bracket and I'm going to close the list with a square bracket and then end with a end parentheses. Go ahead and hit enter and we get our sum. Question number 4. This is now a quiz question. A function all returns whether all booleans in a list are true. Call all with a list of booleans as input. Recall booleans are true or false with capital T and capital F. Give it a try. And here is now the solution. We're going to type in all, parentheses to call the function, and we're going to create a list of booleans with a square bracket for a list, and then we're going to type in true, false, false. End the list, end the function call, and hit enter. Question 5. Here's now a quiz. A function any returns whether any boolean in a list is true. Sorry, this is a typo. Here, let me go ahead and fix that right now. Call any with the list of booleans as input. Give it a try. And here's the solution. We type in any and then give it a list of true, false, false, end the list, end the function call, hit enter, and there we go. Question number 6. This is now a practice question. A string method lower takes 0 arguments and returns a lowercase version of the string. Lowercase this string. Give it a try. And now let's see the solution. We're going to type in ha 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 and To call a method, remember you need dot and then the method name. In this case, the method name is lower. And there are 0 arguments, so we just add parentheses with nothing in between. Go ahead and hit enter, and there we go. Question number 7. This is now a quiz. A string method lstrip takes 0 arguments and removes leading spaces. Leading spaces are any spaces that the string starts with. Go ahead and remove all leading spaces from 𝐴. Give it a try. And here's now the answer. We're going to type in the string that we have from before. Here we have double quote space 𝐴, and we're going to write dot lstrip with no arguments. Hit enter, and we've removed all leading spaces. Question number 8. This is now a practice. A string method ends with takes one string argument and returns true if the string ends with that argument. We want to check if 𝐵@d.com ends with .com. Give it a try. And here's now the answer. We're going to type in double quote 𝐵@d.com, double quote, dot ends with, and we're going to have another string that is .com. And this should give us true as expected. Question number 9. This is now a quiz. A string method starts with, takes one string argument and returns true if the string ends with that argument. Check if Mr. Bean ends with Mr. Starts with Mr. Give it a try. And here's now the solution. We're going to create the string Mr. Bean, and then we're going to type dot starts with. And here we'll have another string that is Mr. And that is also true. Question number 10. This is a quiz question. A string method find takes one string argument and looks for that argument in the original string. Find the position of Cali in supercalifragilistic. Go ahead and give it a shot. Here's now the answer. We're going to type in supercalifragilistic dot find and then a string Cali. And it's at position 5. Question number 11. A string method count takes one string argument and counts the number of times that argument appears. Find the number of I's in Mississippi. Give it a try. And here is now the solution. We're going to type in Mississippi and dot count I. And it shows up 4 times. Question number 12. A string method replace takes 2 arguments, replacing all instances of the first string with the second string. Replace all A's in ha 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 with E's. Give it a try. And here's now the solution. We're going to type in ha 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 dot replace all A's with E's. Hit enter, and there we go. He. Question number 13. Here is now a quiz question. Replace all Bobs with John in Bob poked Bob's dog. Give it a try. And here's the solution. We're going to type in Bob poked Bob's dog dot replace all instances of Bob with John. Hit enter, and there we go. John poked John's dog. Oh, I forgot to clear so that you don't get stuck in the bottom part of the screen. I'm going to click on clear in the top right, and if you do the same, make sure to click into the window, hit enter, and ensure there's an orange caret. Question number 14. A dictionary method values returns all values in the dictionary. Return all values in the following dictionary. Give it a try. And here's now the solution. Go ahead and type out that dictionary, and then :2. Again, these spaces are optional. I just follow that convention of adding a space after these colons. Go ahead and type in now dot values. Right, so before we had a bunch of string objects where those string objects had some methods. Now we have a dictionary with a method. So go ahead and hit enter, and we get the values for this dictionary. Question number 15. Here's now a quiz. A dictionary method keys returns all keys in the dictionary. Return all keys in the following dictionary. Give it a try. And here's now the solution. We're going to have A1, B2 dot keys. Hit enter, and there we go. Question number 16. Say you have a string. And this string is just a comma. The string method join accepts a list of strings as input. For example, this comma dot join of this list produces A, B, C. Use join to convert a list of URL pieces into a full URL. For example, from a bunch of these chunks, google.com, mail, and hi, to google.com/mail/hi. Now you may think that this is cheating because I kind of gave you the solution right here with an example. But in reality, this is what happens when you Google a function or a method online. You'll see a bunch of examples that follow the definition of the method or function. So in fact, this is a fairly reasonable expectation to have when you're trying to use a function. Go ahead and give this a shot. And here's now the solution. We're going to write out the /string dot join, and then we're going to pass in the list of strings, google.com, mail, and then hi. And make sure to end your list and then end your function call. Hit enter, and there we go. This is a particularly challenging question just because this is a really, really weird Python syntax. But this is just how Python does it. This is how you combine a bunch of pieces of strings with some sort of separator. In this case, the separator is a slash. Once again, check how are you doing? This was a difficult section. Note that in reality, you can always Google how a function or method is being used by others. You can also try the function or the method in the interpreter to see how it works. As a result, there's no need to memorize these functions or these functions' usages. You just need to know what calling a function or method means, which you've now done dozens of times in this video. So if this is doable, great. If this is barely doable, don't worry, keep going and you'll build familiarity as we progress in the subsequent lessons. If this wasn't doable, that's also okay. Just watch this video and the previous one again. Each time you rewatch, the concepts will sink in a little bit more. If you feel that you've mastered this lesson, try to come up with a few extra questions and solutions. Leave them in the discussion section of the class, and your fellow students will thank you for the extra practice. That's it for Lesson 5's guided exercises. In this lesson, we will cover code that allows us to change the code we run based on a condition. Start by navigating to pytwiddle.com. As usual, I have it pulled up on my right-hand side already. An if statement runs code if a condition is true. Here's what that looks like in pseudocode. If a condition is true, run code. So let's formalize this now with some code. Start by writing if. Then add your condition. In this case, the condition checks that x is less than 5. Add a colon at the end of the line. Don't forget this colon. Then add 4 spaces at the start of the next line. These spaces are also extremely important. Don't forget these. Finally, add the code that will run if the condition is true. Here, statement really just means any piece of code. Here are all the parts annotated. For an if statement, we need the if, a colon at the end of the first line, and 4 spaces before every line that we want to conditionally run. We can change the condition in brown to anything we want, and we can also change the expression in orange however we want. Let's try this in code. Unlike in previous interactive lessons, we will write code directly in the file editor in the top half of pytwiddle. This is because we will now be writing more complex code that spans multiple lines, and the file editor makes it much easier to edit multi-line code. First, define a value for x. X is equal to 3. Then, write your first if statement. Copy the if statement from the slides. Don't forget the colon at the end of the first line. Hit enter. Here, the editor should automatically add 4 spaces for you. If it doesn't, add 4 spaces manually. Type in x is equal to 10. Hit enter again, and make sure to dedent out of the if statement by hitting backspace. Your cursor should now be aligned with the start of if. Let's print the value for x. Before we run the program, what do you think the final value of x will be after this if-else statement executes? Pause the video here. Here's the answer. Since x is equal to 3, x is less than 5. So the condition is true. Since the condition is true, x is assigned to 10. As a result, we now expect x to be 10. Let's double check ourselves by hitting run in the top left. And there we go. X is 10 as expected. Let's test that the opposite works too. Ensure the if block doesn't run if x is greater than or equal to 5. Change x's value to be any value greater than or equal to 5. I'll change mine to 8. Hit run in the top left. And there we go. Since x is no longer less than 5, the if block should not execute. As a result, we expect x to remain equal to 8 after this code executes. To recap, this code on the left-hand side says, if x is less than 5, assign x to the value 10. That's not all though. The if statement has one more optional part. You can also add an else statement. The upcoming code runs if the condition, x is less than 5, is not true. Like before, add 4 spaces. Then add the statement to conditionally run. These are all the parts annotated so far. And here's the full if-else statement annotated. Now you may hear the term block when coders describe parts of this if-else statement. We call the first 2 lines the if block, and we call the last 2 lines the else block. For example, say x was previously 8. Since x is not less than 5, the brown condition is false. As a result, we say the else block executes. The else block then reassigns the variable x to 2. So in summary, if x was previously 8, x will be 2 after this if-else statement executes. Let's try this now. Let's first augment our if statement up here to include the else block. Hit enter and make sure to dedent before typing else. Else should be aligned with if. Again, don't forget our colon after else, and make sure that the next line is preceded by 4 spaces. X equals to 2. Remember that x is 8 before we run this if-else statement. After this program executes, we expect x to become 2. Now hit run in the top left to execute the program and double check ourselves. As we expected, we see 2. Now let's change x's value to be any value less than 5. I'll change mine to 2. Since x is less than 5, the if block should execute and x should become 10 again. Hit run in the top left to execute the program. And there we go, x becomes 10. Let's write one more if-else statement using strings instead of numbers. Here we'll delete our code and now type in name equals to Bob. Notice that we used one equal sign to assign a value to a variable. Recall from our earlier lessons, to check for equality though, use 2 equal signs. As a result, to check if the name is equal to John, we use 2 equal signs. Don't forget your colon. Hit enter, and again you should see 4 spaces. If not, manually add them. If the condition above is true, then we print out the string name verified. Else, and again remember else should be aligned with if, print out the string unrecognized name. Now hit run in the top left of the program. This time the condition is not true. Bob is not equal to John. As a result, the else block runs and the program prints unrecognized name. Let's recap. In this lesson, we covered how to write an if-else statement. Specifically, if a condition is true, we run the if block. In this case, it would be x equals to 10. If the condition is not true, we run the else block. In this case, it's x equals to 2. If you'd like to access and download these slides or view completed code for the example in this lesson, visit this URL. In the next interactive lesson, you'll learn how to write your very first loop. In other words, how to run a piece of code repeatedly. In this lesson, we'll write a nifty tool that computes the number of days until your next birthday. You could use this to compute the number of days until your favorite holidays, for example. To do this, we'll need to combine all of our knowledge so far about calling methods, functions, if statements, and more. Start by navigating to pytwiddle.com. Let's use datetime as an example. A datetime is a type of object in Python. We can create a datetime object by calling the datetime function. This function takes 3 arguments, the year, the month, and a day. Let's create a few of these datetime objects. In this lesson, we'll start by exploring some code in the interpreter in the bottom half of pytwiddle. First, from the library called datetime, import datetime. For the purposes of this lesson, we will say that datetime here is a function that returns a special datetime object. Now we can construct any date and time we want. As we said before, datetime takes several arguments. The first argument is the year, the second is the month, where 1 means January. The third argument is the day of the month. For example, this date right here is January 1st, 2030. Hit enter. The datetime objects also have additional arguments that represent the hour, minute, and seconds. For example, we can write 2050 for the year, May 1st at noon. Hit enter. And you can see that the output is another datetime object. Let's assign this object to a variable called dt. dt is equal to datetime, and now we'll write 2030 March 15th. As we discussed before, objects have certain methods. In this case, datetimes have a weekday method, which tells you which day of the week that date is. As a recap, here's how you call a method. The weekday method doesn't take any arguments here. Let's try this. dt, which is our datetime object, dot weekday, and hit enter. You'll see 4 in our case, which corresponds to Thursday. There's also a datetime method called isoformat, which converts the datetime format back into a string, dt.isoformat. Hit enter. Datetime objects also have attributes for each piece of the date and time. For example, there's an attribute that tells you which year the datetime represents. As a recap, to access an attribute, use dot notation. Write the object, a dot, then the attribute name. Let's try this now. dt.year. This gives us 2030. Remember from above, our datetime is 2030 March 15th. There are also other attributes. For example, we can access the datetime's month, dt.month, which we expect is March, or 3. There's also dt.day, which we expect is 15. Let's now create a second datetime for that year's New Year's Eve. dt2 is equal to datetime 2030 December 31st. Hit enter. Then we can do something interesting. Before, you could compare numbers to see which is bigger. Here, we can do both with datetimes too, compare and subtract. For example, we can compare datetimes to see which is in the future. dt2 is greater than dt. We can also subtract the two to get the time between them, dt2 minus dt. Now this is a new data type we haven't seen before. It's a new object, a time delta object. Like the datetime object, it has a few useful attributes and methods. Let's assign this time delta to a variable to work with. Diff is equal to dt2 minus dt. Now let's check the time delta object's attributes. There's a days attribute that tells us how many days between the dates dt2 and dt. Diff.days. Here we can see that it's 291 days between the New Year's Eve of that year and March 15th of that year. There's also a total seconds method, which expresses the number of days in seconds. So here we have total seconds. That's a lot of seconds. And that's it. There's no need to remember all of this functionality. We're going to use just a subset of this right now. The goal is to get you familiar with datetime objects. Now we will write a program that reports the number of days until your next birthday. We'll be using the file editor instead of the interpreter now. Like before, import the datetime function from the datetime library. From datetime, import datetime. Before, we said that datetime was a function. In reality, datetime is not a function. It will take an entire course to explain what datetime actually is, so for now, ignore what it really is. The important part is that datetime actually also has methods. One of its methods is called now, and now returns the current datetime. Assign the current datetime to a variable called now, datetime.now. Let's create a datetime that represents your next birthday. To do this, we'll first create a datetime that represents this year's birthday. Next bday is equal to datetime now year, which means the current year, and I'll put October 10th here, but you can do whatever month and day you want to. However, say it's just 2 days past your birthday. This year's birthday has already passed, so this year's birthday is not the next birthday. So we will now use an if condition to check if this year's birthday has already passed. If next bday is less than now, if this year's birthday has already passed, increment the year by 1. So we consider next year's birthday as the next birthday. Next bday is equal to next bday dot replace. And here, the replace method takes one argument, or the first argument it takes is the new year. Now dedent out of the if statement body. Your cursor should be aligned with the start of if. At this point, compute the difference between the next birthday and today by simply subtracting them. Diff is equal to next birthday minus now. Count the number of days until the next birthday, and finally, report the number of days. Hit run in the top left to see how many more days until your birthday. Here we have 137 days until October 10th. And that's it. You now have a countdown until your next birthday. Here's a recap of what you learned. We've learned how to create datetime objects, reviewed how to access attributes of items, and learned how to compute time deltas. If you'd like to access and download these slides or view the completed code for this nifty tool, visit this URL. And in this way, you can now make countdown timers for all of your favorite dates, your friends' birthdays, important work deadlines, or your favorite holiday. On to the next lesson. In this lesson, we will learn how to run a piece of code repeatedly using something called a while loop. Start by navigating to pytwiddle.com. As usual, I have it pulled up on my right-hand side already. A while loop iterates over a piece of code multiple times. It continues to iterate indefinitely while the condition is true, or as I've written here, until a condition becomes false. In other words, while some condition is true, keep running some code over and over again. Start by writing while. Then add your condition. In this case, the condition checks that x is less than 5. Add a colon at the end of the line. Don't forget this colon. Then add 4 spaces at the start of the next line. These spaces are also extremely important. Finally, add the code that will keep running while the condition is true. Here, each time the orange expression is run, x will be incremented by 1, as we discussed in the previous lesson. Here are all the parts annotated. For a while loop, we need the while, a colon at the end of the first line, and 4 spaces before every line that we want to run repeatedly. We can change the condition in brown to anything we want, and we can also change the expression in orange however we want. In sum, while x is less than 5, increment x by 1. Say x was previously 0. After running this code, what would the value of x be? Pause the video here and ponder for a moment. After running this code, x will be 5. In the first pass, x is equal to 0. So in the brown, we see that x equals to 0, which is less than 5. So we then run the while block, which is the orange right here. We increment x by 1, now x is equal to 1. 1 is still less than 5, so we increment x by 1 again. Now x is 2. 2 is still less than 5, so we increment x by 1 again. And we keep doing this until x is equal to 5. Then 5 is not less than 5, so the while loop stops. The final value of x is then 5. Let's try this out. In your PyTwiddle editor, we're only going to operate in the file editor in the top half. First, define a variable x to be 0. Then, copy the while loop from our slide on the left, while x is less than 5. Hit enter. Again, it should create 4 spaces for you automatically. If it doesn't, add those 4 spaces manually. Here we're going to add an extra print statement so we can see how the value of x evolves. Print of x. Then, increment x by 1. Finally, at the very end of your program, make sure to dedent so that your cursor is aligned with while, and type in print of x. Hit run in the top left, and you should now see a number of different outputs. This is what we discussed previously. Let's start with x is equal to 0. In the very first iterate, 0 is less than 5, so we execute the while block. We print x, and then we increment x by 1. That print is right here, the 0. After we've incremented x by 1, x is now equal to 1, which is again less than 5, so we execute the while block again. We print x, which is 1, and then we increment x by 1. And we keep doing this. We keep incrementing x by 1 until we get here to 4. Now, 4 is less than 5, so we print 4, and then we increment 4 by 1. X is now 5. 5 is no longer less than 5, so we terminate this while loop. And we finally print 5 at the very, very end. To recap, here's how to define a while loop. Use the keyword while, a condition, and the code that will loop repeatedly until the condition is false. If you'd like to access and download these slides or view completed code for the example in this lesson, visit this URL. In the next interactive lesson, you'll learn about a different way to loop, called a for loop. In this lesson, we will build a nifty tool that generates food-themed filler text for us. This is useful for designers looking to generate lorem ipsum, but with a twist. It's bacon ipsum. For this nifty tool, we'll directly write code in the file editor. From the requests library, import the get function. At a high level, we're again going to ask the user for input. This time, we ask for the number of sentences of filler text to generate, and even better, we're going to add input validation. If the user inputs an invalid integer, the program will ignore the input and continue to ask the user for input. To do this, create a variable called sentences and assign it to an empty string. Now, we will keep asking the user for input until the user provided input is a valid integer. For this, we can use a while loop. This while loop will continue to loop so long as the variable sentences does not contain a valid integer. So, fortunately, there's a string method called isDigit, which tells us if the string is a valid integer. And we want to check if the string does not contain a valid integer. So we write not sentences.isDigit. Don't forget your colon. Hit enter, you should see 4 spaces. On each iterate of the while loop, prompt the user for the number of sentences to generate filler text for. Here we'll write sentences is equal to input of number of sentences. Now, let's test our program so far. Click Run in the top left. Now try providing all sorts of random input, like letters, maybe punctuation, and your program should stop asking you for input only after you've provided a valid integer. Once you've verified your program is working so far, come back to the file editor to make some more changes. Now, hit enter and make sure to dedent out of the while loop. Again, your cursor should now be aligned with the start of the while statement. Construct the URL that will provide us with food-themed filler text. URL is equal to https baconipsum.com/API type equals to all-meat and sentences is equal to plus sentences. To explain what's going on here, these values, keys and values after the question mark are called query parameters. They pass parameters to the URL 𝐵𝐞𝐬𝐵𝐾_API, just like we pass arguments to functions. Here we write sentences is equal to the number of sentences that we've collected from the user, and type is equal to all meat. We don't need to know these arguments. In short, what's important to know is that these are arguments, and this is how you pass arguments to a URL. Now use our get function to fetch the web page's contents. Assign the response object to a variable named response. Now get the returned JSON as a dictionary and assign the value to a variable called paragraphs. The 𝐵𝐞𝐬𝐵 website returns a list of paragraphs. Let's grab the first paragraph. Remember, we index into a list by using square brackets and the index of the item. Because of zero indexing, the first item is actually at index 0. Let's assign that to a variable called paragraph, and finally, output the paragraph of content. Hit run at the top left, type in a number of sentences, keep it small, like 5 to 10. And there we go. This wraps up our filler text tool. And our program gives us a bunch of food-themed filler text. You can now use this to fill text in design mockups or provide sample inputs to a program. On to the next lesson as usual. In this lesson, we'll talk about a different way to run code multiple times. Start by navigating to pytwiddle.com. Let's start with a new function, range. Range takes one argument, the number of items in the range. Let's see what this range function returns. An iterable. We'll see this in action now in the interpreter in pytwiddle. Let's start with the interpreter, like we said, to explore a new function we haven't seen before. In this lesson, we'll use a new function called range. Call range with a number like 5. Hit enter. Range returns a special data type. We can see there's a range object that ranges from 0 to 5. The specific data type is not that important. However, there are a few facts we do need to know. First, the range object is iterable. Second, an iterable is anything you can iterate over. Let's store the returned iterable in a variable. Iterable is equal to range of 5. There's one more fact to know. We can convert any iterable, like this one, into a list. All we need is the list function. This function list turns an iterable into a list. This lets us see what is in the iterable. This is perfect for range. So let's use list to see what's in the range iterable. Call list on the returned iterable. And now you can see the contents of the range iterable. Range effectively returns a list of numbers from 0 up to the number you inputted minus 1. We inputted 5, so the list of numbers goes from 0 up to 4. And there are 5 total numbers in this list. Now let's use the range function to write for loops. First, consider the iterable we want to loop over. We want to loop over all the numbers in the range from 0 up to 4. To iterate over this range, we will use a for loop. The characters in black, for, in, and the colon are all required parts of a for loop. The green item variable I is assigned to the next value in the range on each iteration. On the first iteration, I is assigned to the first value in the range, a 0. On the second iteration, I is assigned to the second value in the range, a 1. On the next, a 2, and so on and so forth. Then, add 4 spaces at the start of the next line. These spaces are important. Finally, add the expression that will run once for every value in the range. There are 5 values in the range object, so this expression will run 5 times, once for each value in the range. Here are all the parts annotated. For a for loop, we need the for, in, and a colon at the end of the first line, as well as 4 spaces before every line that we want to run repeatedly. We can change the item variable I in green, the iterable in brown, and the expression in orange to whatever we want. Let's try this now in code. Now we're going to write multi-line code again, so let's write code in the file editor instead. Write your first file loop by copying the code on the left. Don't forget your colon at the end of the first line. Hit enter, you should see 4 spaces, and in the for loop, output the value of I so that we can see I evolve. Hit run in the top left to run your program. And you'll now see the values 0 through 4 printed. This is because the loop ran 5 times. For the first iterate, I was 0. For the second iterate, I was 1, and so on and so forth. Now, let's try a for loop on strings. First, a string is also an iterable, so we can pass that iterable string into the list function. Let's see what happens when we call this on a string in the interpreter. List of hello world. And here you can see we get a list of letters, 1 letter at a time. So if we iterate over a string, we will get 1 letter at a time. Let's try this in the file editor now. Replace our existing code with for I in a string hello world. Print of I. Hit run the top left, and as you can see, the program prints 1 letter at a time. Let's recap. We learned how to use for loops. For loops enable us to iterate over an iterable object. In the brown here, each item in the iterable is assigned to the variable I in green. And finally, the code in orange is executed repeatedly for each value in the iterable. If you'd like to access and download these slides or view completed code for the example in this lesson, visit this URL. This concludes the for loop lesson. In the next interactive lesson, we'll talk about how to define our own functions. First, do you use a password manager? If you don't already, you probably should. I personally use Google Passwords, and one of my pet peeves is when Google doesn't recognize a password field on a registration page. Then, Google doesn't suggest a new randomized password for me. So let's create a nifty tool that will create randomized passwords for you. As usual, we will start working in the file editor. Start by importing from 2 libraries this time, directly in your file editor. First, from the library random, import the choice function, which we saw earlier. From the library string, we will also import a few strings that contain letters, numbers, and punctuation. Previously, we've only imported functions from libraries. You can import any data type, not just functions too. Booleans, strings, numbers, you name it. In this particular case, we've imported strings. You can also import multiple values from a library at once, as long as you separate the names by commas like we've done here. Now, concatenate all of the strings that we just imported here into one large string. Characters equals to ASCII letters plus digits plus punctuation. This large string represents all of the possible characters our password can contain. Now prompt the user for the password length using the input function that we discussed previously. Extract the integer from the stringified integer using the int function. Now we build the password by starting from an empty string. On each iterate of a for loop, we will then build this password character by character. So let's write a for loop now that iterates length number of times. Notice that we define the item variable to be an underscore. The underscore is Python convention for a variable that we won't actually use. In this case, we just want to run code length times. We don't need to know which step of the loop we're on. So just like in a previous nifty tool, we now use the choice function to select at random from a set of items. In this case, pass the string of characters that contains possible characters for our password. Choice can take in a string, a list, any data type that can be iterated over. Next, add the newly sampled character to our password. Make sure to dedent out of the for loop. Your cursor should be aligned with the start of the for loop. Print the password we've built up. And hit run in the top left of our program. Enter in the length. I will do 10. And there we go. We've now got our very own password generator. Now you can use this nifty tool to generate randomized passwords for yourself. In the previous lessons, you learned how to use existing functions. In this lesson, we'll actually create our own functions. Start by navigating to 𝐵𝐸𝐻𝐿.com. First, how do I define a function? As we mentioned before, think of functions from your math class. As a recap, functions accept some input value and return some value. Consider the square function. It takes in a number x, multiplies x with itself, and returns the squared number. Let's now define the square function. Start every function definition with def. Then add the function name. Add parentheses, like you're calling the function, but this time make sure to also add a colon. Add your input argument. In this case, our function square accepts only one argument. Then add 4 spaces at the start of the next line. These spaces are how Python knows you are now adding code to the body of the function. Since this function is simple, the first and only line of our function is a return statement. The return statement stops the function and returns whatever expression comes next. In this case, the expression is x times itself. Here are all the parts annotated once more. Note that all parts in black are needed. To define any function, you will always need def, parentheses for the input arguments, and a colon to denote the function is starting. The function name, inputs, and expressions can all change. You also need the return statement to return values to the programmer calling your function. Let's try this now. Like at the end of the last lesson, you will now write code in a file instead of in the interpreter. In the top half of the editor, copy the code on the left-hand side. Def square x, and don't forget your colon. Hit enter, and the editor should automatically add 4 spaces for you. Type in return x times x. Make sure your code runs by hitting run in the top left. Down below in the output console, there should be no error, just the 3 arrows that denote the interpreter. Now, let's see how to use this function. How do I call my own function? Just like you would call any other function, use parentheses and pass your input argument in. In this case, we pass in the argument value 5. Let's see what happens to this 5. Your function accepts an argument x, and we see that this argument x is used in the function's expression. Since we called square with the argument 5, the square function replaces all x's with 5's. The expression is now 5 times 5, or 25. Your square function then returns the value 25. Now let's try calling the square function in code. Still in the file editor, let's call our brand new function. Hit enter to create a new line. Make sure to delete all the spaces before your cursor, and your cursor should now be aligned with the start of def. Now we can call your brand new function, just like you would call any other function. Assign the returned value to a variable called result. Then we need to output the value of that variable, print result. Click run in the top left, and as expected, we get the square of 5, which is 25. Let's try a few more values. Replace 5 with -1. Hit run in the top left, and you get +1. And let's do this one more time. Replace -1 with 3, hit run in the top left, and we get 9. You've now defined and used your very first function. Let's recap what we've talked about in this lesson. Here's how to define a function. Use the def keyword, the function name, specify the arguments, and fill in the body of the function. Every line in the function must start with 4 spaces. To return output, use a return statement along with an expression. If you'd like to access and download these slides or view completed code for the example in this lesson, visit this URL. You can now define custom functions as needed. This is actually all the concepts we wanted to introduce in this course, so we will build one last nifty tool using many of the concepts we've learned so far. In this lesson, you'll build a program that allows you to send secret messages to your colleagues. Although this isn't the most practical example, it's hopefully a fun one. Start by navigating to 𝐵𝐸𝐻𝐿.com. let's use what's called a Caesar cipher. The Caesar cipher works by mapping each letter to another letter. In particular, each letter is mapped to another letter that comes 13 letters later. A is mapped to N, B is mapped to O, C to P, and so on and so forth. But here's the interesting part. Since there are 26 letters in the alphabet, this also means that if we apply the Caesar cipher twice to a piece of text, you get back the original. An A is mapped to N, and an N is mapped right back to A. B is mapped to O, and O is mapped right back to B. Now, let's code this up. Again, in your file editor, start by importing your web page reading function. From requests, import get. Now, access a custom URL I've set up for you. This URL contains the Caesar cipher mapping as a dictionary. Here we'll get the following URL, which I'll show in the slides here. https://alvin1.com/coding101/cipher.json. Don't forget the HTTPS. Here at the very beginning, I'm going to assign this return value to the variable JSON. Next, let's convert the JSON into a dictionary using the JSON method. Then, create a function called cipher, which will compute the secret message. This function takes in one argument, which is the original text. Start with an empty text for the secret message. Iterate over each letter in the original piece of text. Recall from what we saw before, we can write 4 letters in a piece of text, or a string. Use the dictionary now to look up the old letter. The corresponding value will be the new letter. So new letter is equal to the mapping of the old letter. And remember, this is the key. This is the value for our dictionary mapping. Now add the new letter to the secret message. Dedent out of only the for loop. Your cursor should now be aligned with for. Return the secret message that we've accumulated. Now dedent out of the functions body, so our cursor is now aligned with def. Ask for the text to encrypt. Text equals to input, text, or the secret. Run the cipher on the user inputted text and assign the result to the variable result. Finally, print the final result. And that completes our program. Hit run and input whatever text you would like. I'm going to input hello. Now, take this secret message, copy it, run your program again, and paste in your secret. Hit enter, and you should get back your original piece of text, in my case, hello. Now, feel free to encrypt any secret message you want and send it off to your friends. To recap, we've learned about the Caesar cipher, which simply maps every letter to the letter that comes 13 letters afterwards. This way, if you apply the Caesar cipher twice, you get back the original text. This is perfect for sending secret messages. If you'd like to access and download these slides, or view completed code for the example in this lesson, visit this URL. This wraps up our last nifty tool for the course. Awesome work. Let's move on to the conclusion for this course. Welcome to some more bonus content, Lesson 6's guided exercises. I'm sure you're familiar with the format by now. There are 3 steps for each exercise. 1, I present an exercise. 2, you pause the video and try the exercise. 3, I walk you through the solution. Some exercises are practice and other exercises are quizzes. You should try testing your knowledge with quizzes. Let's hop right in. Go ahead and navigate to alvin/coding101/exercises 6. You'll then be greeted with a page like this one. In the top left, you can click on the name of the repl.it and click on fork. You'll then see an editable version like this one. Notice that I've changed the layout. You'll now be using the file editor on the left half of the screen instead of the interpreter on the right. Instead of an orange caret, you should be looking at the section of the page with a line number, 1, 2, 3, so on and so forth. On this screen, I'm going to minimize the left-hand tab here by clicking on Files. And then I'm going to drag on this center cursor so that my file is a little bit larger. All right, let's go ahead and start off with question number 1. For this first question, we have a practice problem. We want to define a function mol3 that takes a number argument and returns that number multiplied by 3. Go ahead and give it a shot. And here's the solution. Let's define the function def mol3 that accepts a single number argument. So here we'll add a parentheses. We'll call that number argument x and then add a colon. Don't forget your colon. Then return x times 3. Go ahead and run to make sure that your function and that your code is valid. Then we can try our function by typing in mol3 and 5, and that should give us 15. Question number 2. This is now a quiz. Define a function sub3 that accepts a number argument and returns that number subtracted by 3. Go ahead and try. For the solution, define sub3, it accepts a single number argument and return x minus 3. We can hit run, and then try sub3, 10 should give us 7. Question number 3. This is now a practice problem. Define a function prod that accepts 2 number arguments and returns the product of both numbers. Give it a shot. And here's the solution. Define prod that accepts 2 number arguments. We'll call these x and y. Returns the product of both numbers. On the right-hand side, we're going to start off by running, and then prod 3, 5 for 15. Question number 4. This is now a quiz. Define a function add that accepts 2 number arguments and returns the sum of both numbers. Give it a shot. And here's the solution. Define add xy and return the sum of both numbers. Go ahead and run, and then we can check add 3, 5 gives us 8. Question 5. This is now a quiz. Define a function prod that accepts 3 number arguments and returns the product of all 3 numbers. I'll go ahead and scroll up a little bit more so you can see the previous solution as a reference. Go ahead and give it a shot. And here's the solution. We'll define prod, and we'll give it 3 arguments and return the product of all 3. Now go ahead and run, and here we now have prod 3, 5, 7, and that'll give us a big number. Okay, cool. Question 6. Define a function gt3 that accepts a number argument and returns whether or not that number is greater than 3. Give it a shot. Now define the function gt3 that accepts a single number argument. We'll call this x and returns whether or not x is greater than 3. Go ahead and hit play or run, and then we'll have gt of 5, and that should give us true. Oops, gt3 of 5, and that should give us true. Question number 7. This is now a quiz. Define a function lt10 that accepts a number argument and returns whether or not the number is less than 10. Give it a try. And now here's the solution. Define lt10 that takes in a number argument and returns whether or not the number is less than 10. Go ahead and run, and then we can check lt10. We'll type in 5, and that'll give us true. Question number 8. This is now a quiz. Define a function both gt3 that accepts 2 number arguments and returns whether or not both numbers are greater than 3. Here's a little hint. Recall that x and y, right, for some arbitrary code, x and y, will return whether or not both of these are true. Give it a try. And here's now the solution. We'll type in the function name, both gt3. This will take in 2 numbers, x and y, and we'll return x is greater than 3 and y is greater than 3. Go ahead and run the code, and in the top right, we can now try this code, both gt3, and we'll type in 5 and 7, and that will return true. Question number 9, this is now practice. Define a function sum3 that accepts a list of numbers and returns the sum of that list multiplied by 3. Give it a try. And now, define sum3 that accepts a list of numbers. We'll call this list LST, and then we'll return the sum of the list multiplied by 3. Run your code, and we can try the code now. Sum3, and this will be 1, 2, 3. This sum should give us 6 times 3 should give us 18. Hit enter, and we got 18. Question number 10. This is now a quiz. A dictionary method values returns all values in the dictionary. Define a function sum v that accepts a dictionary and returns the sum of all values in that dictionary. Now, use your function sum v to compute the sum of all values in this particular dictionary. Let's go ahead and define, go ahead and give it a shot first. Now, let's go ahead and define this function, def sum v. This will take in a dictionary, and it will return the sum of all the values. So here we'll do sum of all the values. And let's go ahead and run this code and try the code. Here we'll have A1, B2. And we get 3 as expected. Question number 11. This is a practice question. Define a function is_Jack1 that accepts a dictionary as input and checks if the number corresponding to Jack in the input dictionary is 1. Give it a shot. And now, define is_Jack1, pass in a dictionary, and then we will check if the dictionary's value corresponding to Jack is equal to 1. Go ahead and run your code. And here we'll write is_Jack1, and we'll type in Jack1, and yes it is. We'll also try a case where this should give us false, so we'll pass in 2. And that gives us false as expected. Question number 12. This is now a quiz. Define a function add3Jack that accepts the dictionary as input and returns 3 more than the number corresponding to Jack in the input dictionary. Go ahead and give it a try. All right, and here's the solution. Let's go ahead and type in define add3Jack that takes in a dictionary. And first, you fetch the value corresponding to Jack, so dictionary of Jack, and then you add 3 to it. Let's go ahead and run this code and try this code. Add3Jack, Jack1, and that should give us 4. And then we'll also try a different value, Jack2, and that should give us 5. Perfect. All right. And once again, we want to check, how are you doing? If this was doable, that's great. If this is barely doable, don't worry, keep going and you'll build familiarity. This was a challenging lesson. We continued to not only build off previous concepts, but also integrate a number of new concepts. Number 3, if this wasn't doable, that's okay. Watch this video and the previous one again. Each time you rewatch, the concepts will sink in a little bit more. If you're feeling you've mastered this lesson, just like before, try to come up with a few extra questions and solutions. Leave them in the discussion section of the class, and your fellow students will thank you for the extra practice. That's it for Lesson 5's guided exercises. Oh, Lesson 6. Lesson 6 is guided exercises. See you in the next lesson. Welcome to bonus content. Lesson 7's guided exercises. In this video, we'll walk through exercises covering concepts from the last lesson. Again, there are 3 steps for each exercise. I will present an exercise. 2, you pause the video and try the exercise. 3, I will walk you through the solution. Some exercises are practice, and the others are quizzes. You should try these quizzes to test your knowledge. Let's hop right in. Navigate to alvin/coding101/exercises 7. You'll then be greeted with a page like this one. Go ahead and click on the top left and click on fork. You'll then have an editable REPL.it just like this one. Start with question 1. Practice. Define a function GT5 that accepts one number argument. If that argument is greater than 5, return yay. Give it a shot. And here's the solution. Define GT5. It takes in one number argument, which we'll call x. If x is greater than 5, return yay. And that's it. We can run this function, and then GT5, and let's pass in 10, and it returns yay. Otherwise, if we pass in 2, nothing happens. Question number 2. This is now a quiz. Define a function reaction that accepts one string argument. If that argument is among us, return yay. Give it a shot. Here's the solution. Define reaction that takes in one string argument. We'll call this string argument game. You can call it whatever you'd like. If game is equal to among us, then return yay. Now we'll try this code and type in reaction, some other game, tic-tac-toe. Nothing happens, but if we type in Among Us, then we get yay. Question number 3, this is practice. Define a function dt5o that accepts one number argument. If that argument is greater than 5, return yay, and otherwise return no. Give it a shot. And here's a solution. Define gt5o that accepts one number argument, which we'll call x. If x is greater than 5, return yay, and else return no. Run this code, and we can now try gt5o. If we pass in 10, then we'll get yay, and otherwise if we pass in 2, we'll get no. Question 4. This is a quiz. Define a function reaction that accepts one string argument. If the argument is Among Us, return yay, otherwise return no. Very similar to the previous questions that we've seen. Give it a shot. Now, here's a solution. Define reaction that takes in game. If the game is Among Us, return yay, and otherwise return else, return no. We can now try this function, hit run, type in reaction, Among Us, and that gives us yay. Reaction of tic-tac-toe gives us no. Question 5, practice. Define a function blackjack that accepts a list of numbers. If the sum of the numbers is less than 21, return the sum. Otherwise, return 0. Give it a shot. And here's a solution. Define blackjack that accepts a list of numbers. We'll call this LST. If the sum of the numbers is less than 21, so if sum of the list is less than 21, return the sum. Otherwise, return 0. Hit run. We'll now try blackjack 2020. This should return 0 because it's greater than 21. And now we try 345, and this is less than 21, so we expect 12. Question number 6, this is now a quiz. Define a function 𝐁𝐞𝐬𝐭 that accepts a list of strings. If the list of strings contains lemon, return the list. Otherwise, return an empty list. Here's a hint. If you type in the following code, hello in list, this will return true if the variable list contains the string hello. Give it a shot. And here's a solution. Define a function 𝐁𝐞𝐬𝐭 that accepts a list of strings. If the list of strings contains lemon, return the list. So if lemon in list, return the list. Otherwise, return an empty list, which is just 2 square brackets with no contents. Go ahead and hit run. And now type in 𝐁𝐞𝐬𝐭, and we'll pass in a list with lemon in it. And that will give us a list back, and otherwise if we pass in a list without lemon in it, then this will give us an empty list. Question number 7, this is a quiz. Define a function laugh that accepts a list of booleans. If any of the booleans are true, return haha. Otherwise, return Here's a hint. The any function will return true if any boolean in the input list is true. Give it a shot. And here's a solution. Define laugh that accepts a list of booleans. If any of the booleans are true, return haha. Otherwise, return Note that this line right here, if any list, could also be if true in list. Right? Very similar to our previous question. So either one of these would work. To test our function, go ahead and run your code. On the right hand side, type in laugh, and we'll pass in a list of booleans where they're all false. That gives us as expected, and then we'll pass in 1 true. That gives us haha. Question number 8, practice. Write a while loop that prints every number from 5 to 10. Here we'll type in I is equal to 5, and then we'll write while I is less than 11, we'll print I, and then we'll increment I. Now we can try running this code on the right hand side. Go ahead and hit run. And there we go. We get all numbers from 5 to 10. Note that you could have also put this, so actually here's an alternative. So I'm going to comment out this code, and here's an alternative solution you could have written. You could have written I is equal to 4, while I is less than 10, I plus equal to 1, print I. Right, so here we'll increment I by 1 before printing. So the first number will be 5, and the last number here will be 10. Right, and just like before, we get the same result. Question number 9. Quiz. Write a while loop that prints every odd number from 5 to 15. Give it a shot. And here's the solution. We can type in I is equal to 5, while I is less than 16. We'll say if I, or here we can actually do something simpler. We can just say print I, and then I plus equals to 2. Right, so that'll give us every other element. The very first element will be 5, and then 7, and so on and so forth. Go ahead and run your code. And here we can see 5 up to 15, all of the odd numbers, as we'd expect. Now, question number 10. Quiz. Write a function print from 2 that accepts 2 number arguments and prints every number from the first argument to the second. For example, print from 2, 3, 6 would print all numbers from 3 to 6. Give it a shot. Here's the solution. Define print from 2, 3, 6, xy. These are 2 variables, not the 2 numbers. So let's go ahead and now use these numbers. We'll say while, let's define an increment, I is equal to x, and while I is less than y plus 1, print I, and then increment I. Let's now try this code. In the very top, hit play to run the code, and type in print from 2, 3, 6, and this will print every number from 3 up to 6. Question 11, practice. Write a while loop that prints every number from 5 to 10 that is not a multiple of 3. Now we can use a while loop while, here we'll start off actually by defining I is equal to 5. And then we'll write I is while I is less than 10, or 11 actually. We will check if I modulo 3 is not a multiple of 3, so we want to check if this is not equal to 0, then we print the value I, and then we increment I by 1. So here we'll check, is 5 a multiple of 3? If 5 modulo 3 is not equal to 0, then it is in fact not a multiple of 3, and we print the number. And then we do this all the way up until we get to 10. Go ahead and run your code, and here we'll see all the numbers that are not a multiple of 3 printed. Question number 12, quiz. Write a while loop that prints every number from 5 to 15 that is not a multiple of 6. You'll notice this is very similar to the previous question. Try it now. And here's a solution. Go ahead and type in I is equal to 5, while I is less than 16. If I modulo 3, 6 is equal to 0, not equal to 0. If this number is not a multiple of 6, then we print the number, and we continue to increment. Go ahead and run this code, and at the very, very bottom, you can actually see that we've now got every number from 5 up to 15 that is not a multiple of 6, so you don't see 12 or 6 here. All right, and once again, we want to check, how are you doing? If this is doable, that's great. This was a very difficult lesson. We combined many of the concepts from before. If this was barely doable, don't worry, keep going, and you'll build familiarity as we go. Number 3, if this wasn't doable, that's completely okay. Watch this video and the previous one again. Each time you rewatch, the concepts will sink in a little bit more. If you have any questions, please don't hesitate to leave them in the discussion section of the class, and I'll be more than happy to answer them. If you feel you've mastered this lesson, try to come up with a few extra questions and solutions. Leave them in the discussion section of the class, and your fellow students will thank you for the extra practice. That's it for Lesson 7's guided exercises. Welcome to bonus content, Lesson 8's guided exercises. In this video, we'll walk through exercises covering concepts from the last video. Again, there are 3 steps for each exercise. 1, I will present an exercise. 2, you'll pause the video and try the exercise. 3, I'll walk you through the solution. Some exercises are practice and others are quizzes. You should try testing your knowledge with these quiz questions. Let's hop right in. Navigate to alvin/coding101/exercises 8. You'll then see a page like this one. I'm going to hit, once you're on this page, click on fork. So click on the title on the top left and click on fork. Then you'll get an editable version of this template. On the left-hand side, I'm going to click on files to minimize this tab, and I'm also going to drag this bar over to the right so there's more space for the code in our file. On the left-hand side, we're going to go ahead and start with question number 1, practice. Define a function printlist that accepts a list of strings and for all strings prints the string on a new line. Go ahead and try. And here's the solution. Define print list. We're going to pass in a list of strings, and for each string in the list, print the string. Each time print is called, the string will be printed on a new line. Go ahead and run your code, and on the right hand side, call print list, and we'll pass in a list of strings. Add a close square bracket, close parentheses, and there we go. Question number 2. A quiz. Define a function print_gt3 that accepts a list of numbers and for all numbers prints whether it is greater than 3 or not. Give it a shot. And here's the solution. Define the function print_gt3 that takes a list of numbers and for numbers in the list print whether the number is greater than 3 or not. Oops, there's no the. Go ahead and run the code, and here we print gt3 and pass in a list of numbers. And there we go. The first two numbers, 1 and 3, are not greater than 3, but 5 is indeed greater than 3. Question number 3. This is a quiz. Define a function print_add3 that accepts a list of numbers and for all numbers prints 3 more than the number. Give it a shot. Here's the solution. Define print_add3. This takes in a list of numbers, and for each number in the list, print 3 more than the number. Run the code, and we can double check that this function works by calling it with a list of numbers. And there we go. We have 3 more than each number in the list. Question 4. Practice. Define a function print_a_names that accepts a list of names and for all names prints the name only if the name starts with an A. Give it a shot. And here's the solution. Define print_a_names and takes in a list of names, and for each name in the list, we can print name, but only if the name starts with an A. Recall from a previous set of exercises that we can check if name starts with A. Run your code, and now let's try this function. We will have a bunch of names with A and a few names without A. Question 5. Quiz. Define a function print_nums_gt3 that accepts a list of numbers and only prints numbers greater than 3. Give it a shot. And now, here's the solution. Define print_nums_gt3 that accepts a list of numbers, and for each number, if the number is greater than 3, print the number. Run your code, and now print_nums_gt3, and we'll pass in a bunch of numbers, some greater than 3. So here 5, 7, and 9 are all greater than 3, so they are printed. Question number 6. This is practice. Define a function getName that accepts a list of names and returns the first name that starts with an A. Give it a shot. Now let's talk about the solution. Notice that here I said returns the first name, not print. So go ahead and define getName. This accepts a list of names, and for name and names, just return if the name starts with A, return that name. So one thing that we haven't quite talked about here is that the return statement actually terminates the function. As soon as this return statement is executed, nothing else in the function will run. So this ensures that the first name that starts with a capital A is returned. Let's run, and let's now use this function. So here we'll have David, Alex, and let's say Emily. And here we get Alex, the first name that starts with an A. Question number 7, quiz. Define a function getOdd that accepts a list of numbers and returns the first number that is odd. Give it a shot. And here's the solution. Define getOdd that accepts a list of numbers, and we'll once again loop through all the numbers. And if the number is odd, then we return the number. We can now run this code and check that the code is correct. 2, 3, 5. And here we expect 3 for our return value. Perfect. Once again, let's check. How are you doing? If this was doable, great. If this is barely doable, don't worry. Once again, let's check. How are you doing? If this was doable, great. If this was barely doable, don't worry. This was a challenging set of exercises. What's most important is that you can read the code and understand how it works. Third, if this wasn't doable, that's okay. Watch this video and the previous one again. Each time you rewatch, the concepts will sink in a little bit more. If you're feeling you've mastered this lesson, try to come up with a few extra questions and solutions. Leave them in the discussion section of the class, and your fellow students will thank you for the extra practice. That's it for Lesson 8's guided exercises. Congratulations, you've number 1, covered a number of different coding fundamentals. Number 2, you've had hands-on experience with code, and 3, now have a slew of nifty tools to use. You've picked up code to begin automating bits and pieces of your day-to-day life. My advice is to start small. Start from the categories we have examples for in this class: manipulating text, calculating dates, or using weather information. There may be an inkling of doubt though. How do I try new categories of tools? I don't know how exactly to write my nifty tool, and that's completely okay. Remember, the goal is to get you interested in and able to look for and read code. What's more important than knowing the right answer is having the interest to continue. If you're stuck, ask ChatGPT or post a question in the discussions tab. You have me and your classmates as a resource. I hope you've had fun, but most importantly, I hope you see now how much utility code can provide today. It doesn't have to be months-long, years-long journeys. Anyone can leverage the power of code, and now you can begin too. Got a super nifty tool? I and your peers would love to try it out. Take a screenshot of your code, upload to the Projects and Resources tab, and don't forget to include a link to your PyTwiddle. I look forward to seeing your projects. I've designed a second course to follow up this one, which covers object-oriented programming, called Learn How to Learn Coding Faster, Object-Oriented Programming in Python. If you're looking to dive straight into different applications of code, you can try my Computer Vision 101 class to experiment with computer vision, the Data Science 101 class to play with data, or the SQL 101 class to query and design databases. There is more content coming to help you ace coding interviews and grow into an advanced Python coder. If these sound interesting, go to my Skillshare profile and click follow to get notified when those classes are launched. Congratulations once more on making it to the end of the course, and until next time.